All right, I'm here with Solomon. Hello.
Hey, Chris.
So tell us a little bit about yourself.
All right, so I'm the CEO and founder of PLAYERIUM, and I've worked in games for about 17 years plus in various roles as artist, as producer, but most recently as founder and CEO of the studio. But most of the time, I'm also a development director on projects. PLAYERIUM is a external development studio in Taipei, based in Taiwan. And we mainly help and work with developers to ship their games. We focus mainly on the technical side. We're a lean boutique studio of about 20 people. And we've been going since 2015 for about 6 years now.
Great. And what are you going to be talking about today?
Today, I'm going to be talking about how we worked with Softstar on Xuan Sword 7 to help them to prototype and prove out certain workflows and processes to reimagine what a next-gen version of their classic IP would look like.
Very cool. Well, let's jump in.
All right. Thank you.
Hi. Welcome. Today I'm going to be sharing with you how we used Houdini to prototype a holistic creative and technical vision for Xuan Sword 7. Before I begin today's talk, I'd first like to thank SideFX for inviting me to be a part of this event, and also Softstar for allowing us to share with you the work that we've done in collaboration with their team on this amazing universe. The contents of today's talk will include some very quick introductions about who I am, our studio PLAYERIUM, and the game Xuan Sword 7, before touching on very quickly about why we chose to use Houdini, and then diving into what we actually created with Houdini, which was the parametric building, assembly and layout HDA and the Rocketfire HDA. Okay, let's begin with the first introduction. My name is Solomon Temowo, and I am the founder and head of development of PLAYERIUM. I've been fortunate enough to have worked in the games industry for over 17 years now, and I've been credited alongside some very talented developers on some very amazing games in a variety of roles, from producer to art director to head of development. And for Xuan Sword 7, the topic of today's talk, my main responsibilities and role was as development director for the prototype, working with Softstar's amazing team to prove out the vision for this project. PLAYERIUM was founded in 2015, and we provide a range of external development support and technical services to developers around the world. We've been credited on some amazing AAA titles. For example, our most recent credits include AAA character support on Resident Evil Village, environment art services on Resident Evil 7, porting services on Galaxy the Virtual, environment art service on Monster Hunter World Iceborne, and development support on Xuan Sword 7, which is the topic of today's talk. Xuan Sword 7 is a game developed and published by Softstar. The franchise has been around for more than 30 years and has 12 installments, including a TV show. It's an original Taiwanese IP with a global cult following. If I could summarize it further in a single sentence, I could say it's like what Final Fantasy is to Japan, but for Taiwan. Xuan Sword 7 is a third-person action role-playing game. Players control the calm and reliable Tai Shi Zhao, who is haunted by a tragic and unfortunate accident and now wants nothing more but to protect his family. But to do so, he must journey through the chaotic realm of Xuan Sword. Combat is real-time based, and players can explore large and expansive environments. Softstar approached us because of our experience in supporting AAA game developers. They asked us to collaborate with them to prototype and explore the idea of what a modernized version of the Xuan Sword series could look like. Why did we choose to use Houdini? Well, we knew that the final game was going to be something that was going to be an expansive, large, open world, and that both teams, ourselves, PLAYERIUM and Softstar, were quite lean in our size. So we needed to find something that would allow us to punch above our weight and work smart and work efficiently. Houdini seemed to cover a lot of bases for us. It allowed great integration and support of other DCC applications like Maya. It also supported a non-linear workflow, meaning that if we needed to go back and edit something, we could do so without having to redo a whole bunch of work. It had some great support for creating some custom tools for production teams, and files could be output from Houdini as a digital asset. Houdini calls this HDAs. These can be used inside other applications like Maya or Unreal Engine. And when you import them, you'll find you can have parameters exposed, allowing you to tweak, customize, and edit that file within other applications without having to go back into Houdini. For the prototype, I'd like to quickly mention some of the other software that we used. We used Unreal Engine as the game engine, Maya for 3D modeling, Substance Painter and Substance Designer for procedural materials and textures, True Sky for our real-time day and night lighting, and for Houdini, we used it for procedural building assembly, layout, and automation, for example, things like LOD, collision. We also used it for VFX, destruction, and we also created what we call an asset processor, or we nicknamed this the Rockifier, which took in simple geometry and converted that into rock-like geometry.
Parametric building layout and assembly. One of the things we wanted to achieve was to allow SoftStar's team to focus on their strengths and not to have to worry about learning Houdini to speed up the world creation and layout of assets. So we created a HDA that would allow them to assemble and lay out building parts and props using simple sliders and toggles. The idea was that their team could focus on generating the parts needed, and the HDA would take care of assembling them, auto-generating the collision, auto-generating the LOD, and just creating general variety. Our first step was to create the building archetypes and the logic that would help to drive these assemblies.
Let's take a look at some of the different ways that these buildings were used in the actual level of the game. The footage that you see before you was captured from the prototype that we developed and completed back in 2017. Let's quickly jump over to Maya and take a look at how some of these buildings are structured and set up. Building parts were set up as modular pieces that were designed to connect together in various combinations. You're probably thinking, why didn't we make these parts as fully procedural inside Houdini? Well, we didn't do this approach because we knew that the production pressures and the scheduling was a little bit tight, and it might not have been practical for us to train up a whole team to create these procedural parts directly inside Houdini. So we decided on this approach where SoftStar could focus on their strengths and allow their production team members to continue just building parts in the applications that they felt comfortable with and knew, but they had to follow specific logic and rules that were defined by the Houdini HDA. Basically, the HDA helped to control the logic of how the building parts were assembled, their layouts and variations, and it also allowed us to plan for a future where we could then automate certain things like automating repetitive tasks like variation or LOD, collisions, or other aspects that could drive blueprint automation inside Unreal Engine. So we're inside Houdini now, and those Maya parts that we just showed you previously, we are using them here to quickly just test that the parts work to our liking. And what you're seeing is the early kind of development testing of these production parts. We wanted to make sure that we could validate the workflow before going too far. And doing this kind of early validation helped us to make sure that we could find any of these kind of unknown unknowns and to just work out any of the kinks in the actual workflow. The results of these tests helped us to kind of refine the logic more, and also allowed us to kind of go back to production and give them more clear requirements of what is needed for them when they make additional parts to add to the library that we'll use to build and assemble these buildings. Let's take a look at how the final HDA turned out. Before opening this in Unreal Engine, we'll just go through some of the parameters that we exposed and show you some of the various variations that can be achieved with this HDA. If you're wondering why it looks so colorful, that's because we've switched on the gray box visualization. We have various different types of visualizations that can be enabled by the user. This is for various reasons, some for speed. So for example, when you just want to quickly improve the performance of how the HDA is running in your DCC application, you can switch to this gray box colorful visualization. I should actually mention that at the time that we created this prototype, we were actually using Houdini version 16.5. Okay, let's add some floors. You can only add floors by actually extending the base out wide enough to allow for the floors to be added. That's intentional. So by widening the subsequent lower floors wide enough, you can add even more floors and more levels. It can get pretty tall. Let me just add in a few more floors here. So each side of the building has its own controllable parameters. So we can do things like randomize the door location or window location on a per side basis. And we can also even change the complete style of the walls, which makes a huge drastic change to the overall feeling of the building. And I think that's where the real power of this HDA comes into play. And we're not just limited to the styles or types of different walls. It's actually on a per part basis. So the doors, windows, roofs, they all have their own different types. And the idea being that Softstar and our team could then focus on just building out more parts and adding to the library, which would then in turn result in greater variation and combinations of what could be achieved with this building HDA. Okay, let's switch over to the game mesh visualization. So in this visualization mode, it's possible to see more fidelity and detail. This could be useful if you just want to get a more nuanced approach of what you're creating. I will switch on the texture mode in a short while, but let's just tweak some settings here with this visualization switched on. I mentioned earlier that for the gray box visualization that people might want to switch this on because of speed. And I just wanted to switch the game mesh visualization on so you can see the difference in the speed a little bit. It's not that much, but when you start to put it into other DCCs and you've got quite a lot of these buildings, you do want to be able to make certain changes quick enough so that you can see the results and make your decisions accordingly about what you want to do with that building. So when I change the wall style here, you'll see that the roof just shifted up a little bit. And we kind of take care of these in the logic of the HDA. We kind of take care of making sure that everything snaps together accurately and correctly. We do. And now let's switch on the actual texture so you can see what that looks like inside Houdini. So here we have the final textured asset. And again, I'm going to cycle through some options so you can get an idea of the speed of how this HDA performs in the textured view. Okay, let's randomize the position of the elements on the front-facing wall. And let's add a door to the right wall. Now let's take the door off. So you can see how easy it is to very quickly kind of make adjustments, randomize things without having to worry about the fiddly snapping of elements together really tightly. And because these parameters are all exposed inside Unreal Engine, we can go one step further and start to automate certain things or create randomized versions or variations of the different buildings that we want. So let's wrap up here and let's jump into Unreal Engine so you can see how this HDA performs and looks like in the Unreal editor. Here we are inside Unreal Engine in the prototype level. The actual name of the level is called Longtan, and we've got some buildings that we've already laid out previously. So just let me find a spot. I'm going to drag out the Houdini HDA. Okay, here will do. So let's drag out the HDA. So as we place here, you can see that it starts off with the gray box visualization. It's the same visualization that you saw in Houdini in the prior sequence. Let's hit that generate button. What that does is it just quickly cycles through some different random configurations. So maybe you just want to quickly place something there so you can just hit that button and randomize things. But if you do want to, customize it a little bit more specifically, then yes, we still have all of the parameters that you saw inside Houdini available inside Unreal Engine. So let's go ahead and start to tweak a few things and create a building. Okay, so I'm going to change the type of wall. Let me just change that wall type. And I'll also change the type of the door. So let's choose a different type of door. And I'm just going to go through some of the same options that was in Houdini. I'm going to go through them and cycle through so you can see, the general performance and the overall kind of workflow of how someone might put this into Unreal Engine map. Okay, and let's switch on the actual game mesh so we can get a little bit more fidelity, see how this looks in the level. So again, you can see it's a little bit more nuanced now, and you can see a little bit more of the detail. So you can see here, as I start to change a few settings, it's a little bit more slower than when it was with the gray box. And that's why we created that gray box visualization, so that if you needed to kind of move faster, then you could if you wanted to. So let's change the door and a few other settings before I go in and switch on the textured view. So let's switch on the material, wait for a little bit. And there you go. Okay, so let's just move it and position it in place. And I was going through these parameters and options very slowly and deliberately, but during production, it's a lot more faster. You can really tweak a few things, and as long as there's additional parts in the library, the HDA will look at those and append them to the list. So you can always choose between those different things. Let's jump back into Houdini and let's kind of quickly look at some of the nodes. I won't go into detail on each of the nodes, but of course you can pause the movie so you can have a look to see how some of these nodes are structured. Or if you didn't quite see what you were looking for, feel free to kind of shoot us an email. We'll be happy to share what we can within reason. But you can see we've kind of structured each of the node groups by the different parts, by the different elements. And I will kind of show you very quickly like what these elements look like in isolation. So another thing to mention about the way that this building HDA is set up, it's that it's reading parts from a directory, a folder structure where we define. And as the production team adds in new parts, the Houdini HDA will automatically append those parts list to the HDA as an option for the user to select from. So let's cycle through some of these parts and just what they look like in isolation within Houdini. So here's the roof, and this is actually made up of like 4 parts. So we've got like the corners, the midsection, the actual top of the roof, and different variations of those sections as well. And they all connect together really nice and neatly, just like Lego blocks. Okay, so I just changed the roof type, and I'll just kind of bring back the rest of the building, and we'll kind of just cycle through a few more options before kind of wrapping this up and then moving on to the next part of this presentation. We knew that the world of Xuan Sword 7 would have a lot of rocks, that there would be sections and parts of the environments where they would be set in a rock-like scenario. So we were thinking, how could we help Softstar to be able to make more of these rocks in an efficient time so that they can spend more time focusing on other areas of the game? So we created what we call the Rockifier. It's essentially an asset processor that takes geometry input and then converts that into a rock. It will automatically apply things like the details that you find in the rocks, the cracks, the material expressions, the crevices, and it will also generate automatic LODs, collision, UVs. So let's dive into Houdini to see how this actually works. So here we have the Rockifier, and it's actually just currently taking a simple cube, and it's actually converting that and auto-generating this rock-like feeling that you see now. So let's kind of go through this in the nodes so you can see how it's doing that. So let's just switch to the box so you can see what the original version of this mesh looked like. So let's go to the box visualization. So we passed the cube through a subdivide and a smooth node before connecting it to a VDB node. This is just to help so we can clean up the topology a little bit. So yeah, this whole section here is what we're using just to kind of clean up the mesh a little bit. It then gets subdivided again and remeshed again because we need this extra fidelity so that we can use it to add more faces for the details that's going to be in the final kind of rock geometry. So you can see when you go really closely, there's a lot of now faces now that we can use to add in a bit more fidelity and rock-like displacement in the actual geometry itself. So let's just switch that over so you can see what that looks like. So yeah, we've got this really basic rock-like feel now, and there's a whole bunch of parameters that we've also can tweak to change the style, feeling, different elements of how we want this rock to be. We're just going to keep it basic for now. So once we're happy with the level of rock kind of feeling that we're getting from the asset, once we've kind of added all the details that we feel needs to be there, we then pass that through another node to create the LODs. We could, of course, create the LODs inside Unreal Engine upon export or as a separate process, but we wanted to let the HDA handle that process. We wanted to avoid a situation where the production team would need to do another step inside the engine where they would need to, add LODs to a specific specification. So we take care of generating the LODs in the HDA. And we generate about 4 levels of LODs. We can generate more, and we can also control the percentage of LOD steps. So in this case here, for the LOD 0, we specify about, I think, 5,000. Let me just double check for that for you in the node itself. So yeah, we specify 5,000 for the LOD 0. And then LODs 1, 2, and 3, they all have their own predefined reduction amounts. And we also expose this parameter so that if they want to adjust it, they can. But we find that it was very rarely needed during production. And let's just quickly switch between the different LODs so you can see what the topology looks like for them. Okay, so that was a kind of a step-by-step process of what the node is actually doing when you input a mesh. We did it on a simple cube. This time around, let's just switch it over to a sphere. We won't go through all the details, but you'll see that it will automatically kind of apply everything that we just did on the cube, but this time around to the sphere. Okay, so here you go. Here's what it looks like on a sphere. So that's what it looks like on very simple geometry. But in the full production, how we were using this was that level designers or artists could make very quick speed models of any shape that they wanted, and then use that as an input on the actual HDA. The HDA also generated the automatic UVs, collision, and also the materials and textures. For the materials and textures, we were actually using Substance Designer, so it would procedurally look at certain things on the mesh data to generate the materials needed for this asset. But the topic of today is mainly focused on Houdini, so we won't dive into any of the Substance Designer related stuff. So the asset I've just opened up now is one of example of the speed model that would be used in production, and that gets fed through the asset processor, and all of the details of the rock, the material expression, the crevices, it's all getting applied to this rock. We also set it up so that it can take in Unreal Engine 4 brushes as an input. So let's just quickly jump into Unreal so you can see that. I'm going to drag out the HDA again, so give it a few seconds. So by default, it will use either the cube or sphere that you saw in Houdini that I just showed you. It will use that as the first kind of base mesh to rockify. It takes a little bit of time, but it's not too long to be overly frustrating. You have to bear in mind that it's also generating the collision, the LOD, the UV, and the texture as well via the Substance Designer. So just a little bit of time, but it's still a lot quicker than if you were doing this by hand and then you needed to do it on a whole bunch of rocks that's needed for the level. So here you go. Here is the rockified mesh. Okay, so let's just look around this a little bit, and I'm going to swap over now to using Unreal Engine 4 brush as an input. So we do this first by selecting the source, set that to 2, and let's select the geometry input. And I'm going to go and drag a basic brush out into the viewport. Let's take this cone. We just move this around a little bit, get it in position. So let's just scale it up a little bit and just move this around. So back to the HDA. This time around, we're going to select Start Selection, select the cone that we just put in, use the current selection, wait for it a few seconds. And you can see that it's using the cone as an input shape, and it's automatically rockified. Now it's a little bit small, so let's just scale this up so it's a little bit more bigger, more easier for us to see. And there you go. We can use any shape as an input. This is just a quick example, but let's jump back inside to Houdini so we can see an example that was used actually in production and the level of detail and that was achieved in the actual production of the prototype. So this is one of the example kind of rocks that was generated for the prototype level, and it's using the Rockifier HDA, and we'll just cycle through some of the nodes so you can see how it works. So this particular node, you can see it's actually generating the rock detail itself. And there's a lot of detail there. You can see there's the cracks, the crevices that I mentioned before. And it's really just adding in that rock feeling. And, we plan to have different styles of rocks in the actual full production. So in that way, we could really let the team focus on just creating simple shapes and then unifying the style through the HDA, unifying the kind of the creative vision and the technical approach through the HDA itself. So we'll just quickly go through a few other visualizations before closing it out on this Rockifier asset. Thank you very much for watching this presentation. And before closing out, I'd also like to thank the PLAYERIUM team for all their hard work, dedication, skill, and talent in bringing this prototype to life. They've done an excellent job, and I'm very proud of the results that they've achieved. So let's wrap this up. This is in-game footage captured in 2017. And if you've enjoyed this talk, and if you have any questions, or you'd just like to say hello or congratulate the PLAYERIUM team, feel free to reach out to us on our social media channels. Thank you and goodbye.
All right, with me now, we've got Miguel Mendez from King. Hey, Miguel.
Hey, Chris, how are you?
Good. So let's start with a little bit about yourself.
Okay, yeah. So, yeah, I started using Houdini quite a while ago. Before joining King 4 years ago, I worked for almost a decade doing flight simulators, and that's where I started to use it because, well, you probably can guess the big data sets that you treat building the environments and super cityscapes and things like that. So that's where I started using it little by little. And then at King in games, I started to find places to use it as well. And well, in cases like Crash, we used it pretty deep into the pipeline.
Right. Well, that's a good segue to what you're going to be talking about today. Tell us a little bit about that.
Yeah. Crash Bandicoot on the Run, it's the latest game that we have released. And we have used Houdini really deep in the pipeline, really closely matched to Unity, which is the game engine that we used. And we used it for the landscapes. We used it for the prototyping, a lot of it, but also in the production. A lot of what you see on screen while playing the game has been through Houdini.
Excellent. Well, can't wait. Let's jump in.
Hey, hello. So very quickly, just in case, my name is Miguel Mendez, and I've been working for 4 years at King as Houdini TA, pretty much all the time. And I've been working on several projects, but today I want to talk to you about Crash. Mostly because it's the first game we have released where we have used Houdini really deeply into the environment pipeline. And it has been an 18-month experience of lots of learning and doing and redoing. And it has been really interesting, and I thought you would like to hear about it and be interesting to you. So first I want to show you the Crash Bandicoot on the Run launch trailer. I think it's on the one side it's fun, but also there's a shot in it where you will see Crash running from the top into a vista through a road, and he will find a junction, and to the right there's a really mountainous icy world, and to the left there's a jungle with pyramids and stuff. And I thought it's really telling of the vision that we had for the game. So I'll let the trailer run, and if you catch that shot, pay attention. It's really cool, all of it. But in terms of environment, that shot is also cool. Okay, that was quite a bit of jumping. It's still fun though. So yeah, coming back to the environments. This is one of the original concept designs for one of the lands. It's called Lost City, and you can see how expansive it looks. And here, I think the idea we had was to create like a really expansive environment that felt big and real, and you would actually go to places. So it would be like a runner on steroids, a runner like no other in the market. It would almost, like really huge places where you would actually have to walk and run your way to get to visit someone or reach some place where it had something that you wanted to get. So in that sense, it was pretty ambitious. And I'm going to show you a capture of the actual final result, which looks like the original concept. The environment team has done a great job here. They have provided all the art captures, by the way. They have done a great job of showcasing the work. And yeah, sure. Coming back to the image, it looks really nice. But if I show you now the gameplay of it, you will see, well, there's a junction that we jump. And if you look at the far end or the sides, it's not nearly as populated. And it doesn't look like you can ever reach that volcano at the end, right? It's just part of the background, not really there. So there was a realization during the making of this game that when you actually play on your phone portrait like this, the real protagonist is Crash, the items, and the road. The road is very powerful, so that's like that's sort of the supporting actor in this play, and the sides are barely visible and not that important. But still, I wanted to show you the original take because it played a big role on how we started working on the prototype for this game, at least on the prototyping of the environment tools. And of course, what we were tempted to do was a traditional approach where we had like a Houdini height fields or unity terrains that you can move between them easily nowadays, and lay down stuff on it. So lay down a road that would blend into it, and and have like an open world game sort of. The truth is that it wasn't a good fit technically for phones. At least the range of devices that we cover with this game, I'm not sure they could do it. But also the authoring of the world and the levels and the art, the workflow is tricky, and it's just like a one big scene with everything in it, or you have to, I don't know. It's complex. Let's just call it complex. Not impossible at all, but it's tricky. And then we had. You will see the variety of lands and how they came out to be. I'm going to show it to you here. Really prove that the terrain approach, the traditional open world or terrain approach wasn't really fit. For example, this temple ruins level doesn't have a terrain at all. There's nothing. There's a floating road. Or every land pretty much has holes in the road, these pits, and you would have a terrain floating there. Or worse, every land has cave systems, so you would have to go through some hoops to just avoid the terrain or just not have it at all. So there's like a lot of tech there that we wouldn't need. Another drawback with the terrain, just very briefly, is that everything tended to be very unique, so very expensive storage and transmission wide. So the whole thing started to feel. At least we started to look into tiling systems. We had already some experience with them. I had done some prototypes of other games in the company that relied on this idea. So I prepared this little group of slides just to tell you a bit of at least how I see tiling systems. And this little bit of pieces, this little collection is what a tile set is normally called. And there's some rules to connect them together. And to me, the one fun fact about putting them together is that you just provide a tiny bit of data. In this case, it would be a really low res, like 8 by 8 pixel height field with even like 2 bits of precision already lets you create this terrain. And the rule set that connects the tiles looks at each pixel and sets the four pieces that meet in that corner, and you get this smooth output and seemingly very unique, but it's all recycling the same little bit of data that this tile set is comprised of. So it's really nice also for mobile devices. And also the workflow is pretty clear. Artists can work on the tiles, while level designers can be working on the environment, well, the levels themselves, and it's super easy to just swap. I'm just swapping between tile sets. Little fun fact, all of these tile sets are done in Houdini, so Houdini can also procedurally generate tiles. So all these variations that a tile set would need can also be procedurally powered. If not done completely, you will see how in Crash we didn't completely, it was impossible, but we didn't completely rely on procedural generation, but the proceduralness of it lets you do the iterations sort of all the combinatorial problem of it. Also in terms of fixing quality stuff, you will see it coming further. So, well, just one more tile set, which is a funny thing. You can make it out of donuts if you want, but we still didn't rely on square tiles like this. But we had an old prototype that at first I didn't remember we had it. It was based on hexagons. It was for another game, but it had a road in it already. And this was a Houdini HDA that used only these 5 pieces. You see, I guess you can see how some of them have a little bit of the road straight or more and more turning, more tighter turn, yeah. And this is the original GIF that I did at the time, years ago, before Crash or anything like that existed in our heads. And you would provide this very little input data, this very rough spline, and it would give you like a nice smooth surface out of just combining these 5 pieces. And you could quickly reshape everything. So the workflow was and the interactivity was nice. And the tiles could be changed and could mature, it could be evolved by the art team while the level was being worked on. And immediately we moved it to Unity just to see how it felt with the current at the time toolset. So we had this nice multi-spline editor in Unity that the Unity tool team, our Unity tool team did, and it felt really nice to combine them. So here instead there is a level of indirection in the original prototype. Crash would run directly on those splines, green splines that you see, but we would need to sort of provide hexagon splines, right? Because the road in the hexagon doesn't exactly match the input data, that green spline. Still, that kept evolving, and that happened. But it was an entirely game developer issue. The issue for me and the environment team, the artists, was how do we create the hexagons themselves? This is another tricky situation. Because there's very strict technical requirements on these tiles when you think of it. They have to perfectly match at the edges. Maybe you want some safety skirts procedurally modeled for them. So there's like a bit more safety there in terms of continuity. Like I said, the topology has to match, and the roads has to be perfectly tangent to each other. You cannot have weird angles. And maybe you want some freedom, and just making them by hand entirely would be, well, complicated. Feasible, but really complicated to have everything looking nice. So my first gut instinct was to make an HDA that would just parametrically and procedurally generate hexagons. And in that sense, it was successful, but only in that sense. So it would give you freedom to change shapes and do stuff to it. And internally, it would be driven and generate also these Bezier segments that the Unity game engine could pull out of the HDA and use them to have Crash navigate this hexagon. Where it failed miserably was with artists. It was impossible to just generate any decent art with this. No matter how much I would try to do procedural art, I couldn't even come close to what the artists were outputting and the concepts. So it was impossible to match. So immediately I started thinking about how to combine the artistic freedom and the amazing capability of these people with the procedural tool. And we came up with this idea of having this is my crappy first model and test, having an input model that would be like the sides of the road that were very important for us in visual terms. And those would be fed to the hexagon builder, and the hexagon would consume them and basically make a hexagon out of that, in that style. So like a tiling system within the tile, not a second tiling system if you think of it that way. And it worked, and we kept evolving it. And this is another example that I digged out from all hard drive archives. And you just hear a different shoulder. We call them shoulders because originally it looked like a shoulder, where the shoulder has changed and it touches at the top. So we make an enclosed area. And also the tool lets you do funky stuff like sliding, copying, reordering. And when we put it to the actual test of making the game, it works. It works really well. And I'll show you how we do the roads as well and how everything matches. But here you can see basically this shoulder on the left is used to generate turtle woods. And similarly, the lab is generated with that idea of the shoulder touching at the top. And we have an enclosed space. Or another example, we even had like huge shoulders. This is just one shoulder, both sides, and the entirety of the hexagon is covered with just one custom model, and we generate hexagons out of that. Meanwhile, while visually it was cool, there were some things that the tool could still help and was good at, and this is where Houdini comes at play as well, because it's great to manipulate minutia and very precisely geometry. So we have two input meshes that they may be unrelated, or at worst, well, basically the road is procedurally generated, and the shoulder on the side is basically an arbitrary mesh. Can have any topology. It just, all you know is that it has an edge. That's the only requirement that you put on the art department. And if you do the sort of the more naive approach of just trying to match them by splitting, you get a huge increase in vertex count, and of course horrible topology. Not good. But Houdini lets you manipulate things as such with such elegance that with Vex and things like that, we were able to just resample the edge without losing any data, vertex colors, UVs, no vertex data, attribute vertex data was lost, but we get a perfectly smooth surface and barely any increase in vertex count. Another area that initially at least was very important, but now it's not so much in the current game, but I wanted to show it to you because of how it proves great uses of Houdini. It can also do heavy computation for you, store it, and then in this case a vertex shader can consume this data afterwards and very quickly calculate something for you and make it look nice. So originally, not in the current game, but originally this open world thing had a great height field. And if you imagine the side of a hill, if you happen to have put your level there, your road, when it reaches the height field, it will be sideways and it doesn't work. The crash will sort of float or go into the road when he changes lanes. So what we did here was to modify slightly the vertex shader and use a pre-computed attribute from Houdini, which basically tells it the offset that it should use, like a vector offset of where to sample the height field. And I'm trying to represent it visually on the right, how the offset makes it sample closer to the center of the road. And then you blend it towards the outside, so you get this flat road, so Crash will walk properly on top of it, and then smoothly goes into the appropriate and sideways of your mountain. Anyway, Houdini is really cool for these things as well. One more thing that we did in Houdini and was to extend the concept of the custom model to the pits and the road itself. So it wasn't fully procedural anymore. And the pits could be modeled by an artist with certain freedoms, certain limits as well on the size and keeping things watertight so everything connects well. But it was liberating for them because then they could build whatever they wanted. This is lava, but they have another land where there's electrified plates, and the electrified plates are less deep, so Crash dies on contact basically, and that model is fed to the Houdini HDA, and it puts the killing collider basically at the proper height, and it gives both freedom and yet it generates gameplay correct content. And to the right is the Unity developer team tool, how it takes these variants and manipulates them to generate all possible combinations, sizes of pits. Really cool. But at the same time, this was sort of an introduction to a problem that we had, and that I think Houdini's great flexibility and procedural approach saved us here. And let me introduce you how the issue came by. So at its very root, the issue was that we took the Bezier curve for granted, or we took it for what it was. It was what the prototype ran on, or the game ran on. And we decided, well, we need to produce Bezier segments for Crash to navigate the world. So let's use them also for modeling. And we can have all this freedom. You kind of saw it in that GIF where we can shape the curves. What's the issue here? A Bezier by definition has no constant curvature. And no constant curvature means that every little chunk of your road, if you split it like we did to the pits, becomes unique. And we didn't do runtime bending of these pieces because we wanted to have perfect matching topology and no precision loss or anything like that. So we pre-bent them, much like the rest of the hexagons. They are pre-bent in Houdini. And this you can expect this data explosion now. I guess in your head you're doing the numbers. Yeah, easily we could have 200 little pieces of geometry in a single hexagon just to have all the possible combinations of road and pits and 1 lane, 3 lane pits, all of that. And it became a real big concern. The numbers were bad. Import times in Unity were bad. Git was under stress as well because there were many hundreds of files changed every day, every time you pull, just from the daily work of the environment team. So people started to say the obvious thing. They are almost circles anyway. It's obvious until, or it's not obvious, it wasn't to me until I was told. And I was like, yeah, it's true. No one is using this freedom that we have to manipulate the Bezier CVs in any way. We were basically stuck with the default value that we were using. So this is where Houdini comes really in handy, its flexibility, because behind the scenes, from one day to the next, all hexagons, we just recooked them all, basically. The ones that had already done, because this happened really late into production. We had more than half, or easily, well, a lot of lands were already in the game. And basically we exchanged using the Bezier splines for modeling. We started using just what you would say circles, constant curvature. So we can reuse every piece is the same as the next. So you can basically reuse them. You only need 10 pieces, not 10 by however many chunks you have in your hexagon. And just for compatibility's sake, Houdini would generate a Bezier spline, but it was just the most similar to a circle spline that we could generate. And only for runtime purposes, no modeling based on that spline, of course, just to have perfect geometry matching. And I thought to show you this slide because it's quite also telling. Right above me here is those green hexagons are V1, and they would let you do all kind of magic that we were not trying to use anyway. And to the right is the hex V2, the straight, since we wanted a slight bend, left, right, bend there even in the straight. It's using 3 tangent circles, and this is a nice geometry problem that it was super fun to do in Houdini. And once you do it in Houdini, it's sort of procedural. You have all the solutions for everything, and you can quickly do these funny animations. All those little colored pieces of the road are basically the same piece, just either rotated and flipping the UVs. So we can, again, reuse everything. There are some numbers for you, but storage went down, but mostly the number of files that were killing Unity and Git went down by a factor of 100. And we did this in the middle of production. This is, again, another incredible feature that you can have with procedural approach. You just redo all the art at once. Anyway, enough for this. I think it's time to show you a bit of the excellent work from the environment team. This is a sample of some of the lands, And you can see, what I wanted to show here is a couple of things. One is the variety, that how expressive these hexagons became, how much artists can express themselves with just populating the shoulders, the pits, and dressing with some prefabs on the sides of these hexagons. They can create huge visual variety. And also another detail is that they don't look like hexagons at all anymore. There's very little effort trying to make them hexagons, which prove this point that I was telling you before about just playing on your hand like this. There was no need for all the hexagons to cover the whole world. Just your field of vision and having a nice road and your focus on what you're focused while playing. But still, there is this nice ambience and feeling of realism of what you're looking at. Anyway, I'm going to leave you showing you a video of this same thing because they look really tiny here. I just want to show you the variety, but now I'll show them to you in a flyby that also the environment team produced, and I think it's really cool. So I'll leave you to it. Let's go. No gameplay here, so we can focus on the environments. Turtle Woods, the original land. And this is the lab of Crash's arch enemy. Really cool. So yeah, this is the end basically of the talk. Hopefully you share excitement of how cool Houdini can be and how deep you can integrate it, how deeply you can integrate it into your game engine or your game, producing all types of art. Here it was environments, and I think it came out really well. Cheers.
All right, I'm here with David and Xray. Hey, guys.
Hey, how's it
long
going?
and prosper.
So let's start with a little bit about yourselves.
Well, my name is David Santiago, and I am currently a principal technical artist at Insomniac Games. Originally, I was an electrical engineer working at the Jet Propulsion Laboratory for NASA, but after a few years, I got into the visual effects industry, worked on a lot of feature films, commercials, music videos, animated films, and then I found my home in video games about 8 years ago at Insomniac Games, and been here ever since. I started on Sunset Overdrive, worked on the Spider-Man games, and now most recently Ratchet and Clank Rift Apart.
Very cool. What about you, Xray?
Hi, my name is Xray Halperin. I'm a senior technical artist at Insomniac Games. I focus on procedural systems, primarily using Houdini as a framework. I got my start in visual effects back when Houdini was just prisms. I was able to work with David on several projects at Digital Domain while working in feature film visual effects. And I joined Insomniac about 5 years ago. It's been a great ride and I'm really enjoying it. Today I'll be talking about the procedural systems for Marvel's Spider-Man Miles Morales.
And I'll be talking about some of the procedural systems we use for production of Ratchet and Clank Rift Apart.
Looking forward to it. Let's jump in.
Greetings, my name is David Santiago, and I am a principal technical artist at Insomniac Games. Today, I'm going to talk a little bit about some of the procedural systems we use to make the PS5 exclusive game Ratchet and Clank Rift Apart. This is just a brief opening act talk before Xray's more in-depth presentation about some of the procedural systems used on Spider-Man Miles Morales. Of course, some of those systems were used on Ratchet and Clank as well. The emphasis of my talk is that simple procedural tools can have a large impact on a project for many areas of production. So what could these simple tools be? You need to look at all the small tasks that people do from day to day. What content will be authored and re-authored? What are the time-consuming and repetitive or iterative tasks? Is there anything that needs optimization or validation that can be defined systematically? Technical or not, all of those tasks are prime for procedural systems to do the busy work normally associated with them. Ratchet and Clank games have a very organic and experimental development process. In production, we used multiple procedural systems we already had in our tools library and developed some new ones. This is not a complete list of the procedural systems used, just a few that had a major impact. Our grind rail generation was aided by a spline to model tool. A traffic authoring system was created specific to Ratchet and Clank's needs. Our regular imposter system was upgraded to work on multiple open worlds and generate imposters for assets that never stream in. And we created a way to author content globally and then distribute to the assets into the appropriate open world streaming regions. So let's start with the spline to model tool. What was the plan for this thing? Well, it was initially just a simple tool to sweep geometry along a curve to help the artists and designers create grind rails. That's something they do over and over again. It's a very iterative development process, and if you have to model it by hand, or even jump into another package to update the rail, that eats up a lot of time. This system lets them author and re-author gameplay grind curves in the Insomniac level editor, and then generates the new models by selecting the curve or curves and running the generation command from a menu. The simple HDA sweeps geometry onto the curves, exports the model, and adds it to the level. This relatively very simple tool takes an all-day task into just 5 minutes of work. Here's part of the interface in the Insomniac level editor. These properties are associated with a curve. When submitted for generation, the properties become attributes in Houdini, defining the content to generate in background Python process. You can see how these properties could be parameters on an HDA, and most of them are. But once I realized no one will be authoring this content from a Houdini session, there was no reason to add parameters to the HDA. The Python-based importer dynamically creates attributes for the properties added in the editor. That means if I added a second UV set to this property panel, it would automatically be added as an attribute when generating the model. Lower down on the same panel, you can see there is the ability to add a second UV set, and there are some additional controls for collision, LODs, and actor properties. There is also a dynamic array added to add multiple instance objects in many ways. One can actually place a collection or library of possible assets that can be randomly or sequentially chosen for placement. For example, if you wanted to place trees, you could have a whole library of trees placed along the curve based on placement parameters. This is one of the very first examples I used to demonstrate the spline to model tool. I generate a 3D path model along that green curve and also instance several asset types along the curve, such as the box that's offset to the left, a character randomly along the path, and some drones from the Spider-Man game. This example uses many features of the original version of the tool. I created a path through Central Park. From this vantage point, we see that I added a collection of different trees for instancing along a curve. If we look inside of the woods, we see there is a paved path along which we have these headless NPC characters, since heads are chosen at runtime. There is also additional vegetation on either side of the path besides the trees that we could see from above. This particular wooded path through Central Park took a minute for me to set up and generate. As I mentioned before, once this tool was out there, the artists and designers came up with all sorts of different ways to use it. One artist authored these off-ramps for Spider-Man Miles Morales just by using a freeway model cross-section on curves leading to the bridge. The tool was used for a lot of design experimentation to make simple models or instance gameplay and design primitives, such as these design capsule cylinders and spheres. One artist decided to use it for procedurally placing vegetation along the edges of areas in Ratchet and Clank. And here's another example that places rocks and vegetation along a stream. Ratchet & Clank Rift Apart has some big cities, so some initial layout used the tool to instance buildings. Here's an iteration that mocked up the parade route in the beginning of the game, and then populated a city around the route. And then here is a second version. And each of these iterations took seconds to generate from the layout curves. And, as was originally intended, here is an example of one of the many grind rails in Ratchet & Clank Rift Apart. The tool also created the special collision geometry in these glitch challenges. These little combat arenas required special surface and bounding collision that's not present in any visible environment geometry. Spline to model was used heavily over many iterations of the challenges, and I only recently found out that it was used much more than I thought. In this frame from Spider-Man Miles Morales, artist Oscar Gonzalez uses it to create all the different cables, from the purely environmental ones in the ceiling to the gameplay-related cables going to that generator on the stage in the Opera House. Again, since many of the cables were gameplay-related with markup, many iterations were required as the design for the mission evolved. That's the last example I have for the Spline to Model tool, although it was used for many other things. Now there is quite a bit of vehicle traffic in various cities of Ratchet & Clank, so we needed an easy way to author and reauthor it. Again, curves in the editor are given specific traffic properties, from which the traffic nodes and markup are generated for the runtime system. The system was much simpler than the traffic system created for Spider-Man, or that was upgraded for Spider-Man Miles Morales, but because of the density, speed, and scale of the traffic flying through the air, some different properties were required. The system simply had to instance and optimize density of traffic nodes along those curves and apply the correct properties to each of those nodes for the gameplay code to process. The number of iterations and adjustments made during production is just not possible any other way. Now here's the traffic system in action. The last tool I'm going to talk about is actually a major production development for authoring streaming regions from globally authored content. We let artists and designers author their content in large zones, pretty much as they had done on previous Ratchet & Clank games. But because of these much larger worlds, the open world experience we wanted, and going back and forth between the rifts, we not only stream regions of a single open world, but between multiple open worlds. Here's an example of an open world map for one of the areas of Ratchet & Clank. Each tile represents a streaming region, each of which contains zones for art, gameplay, lighting, audio, effects, etc. The open world system loads in the high-resolution geometry, lighting, audio, and gameplay for the tiles around the player. All the other tiles remain in low-resolution representations, such as imposters with distant lighting data. The system automatically sets up the open world region per planet based on its content, streaming the lighting, gameplay, art, and effect zones. The art instances are moved to the streaming art zones. Large models are cut into smaller models with LODs and placed into those streaming art zones. Sometimes many much smaller models are needed to support gameplay physics. Gameplay elements are moved to the streaming gameplay zones, checkpoints, crates, covers, etc. Background environmental pieces are moved to background streaming regions, so only imposters are ever used in the game. Multi-region elements of art and gameplay are moved to open world global regions, which are always loaded when that level is loaded. Here's an example, falling through a rift, going from one open world to another. This procedural system was the most complex used on Ratchet & Clank Rift Apart, but the greatest impact on game production was from our set of smaller procedural tools.
My name is Xray Halperin, and for Spider-Man Miles Morales, I created several procedural systems to enhance the game. The open-world environment of Spider-Man Miles Morales is divided into 735 tile regions. Each tile region is defined by several zone files, which are JSON that contain references to the assets within a given game. In many workflows, each tile may be expressed as a work item in Houdini's procedural dependency graph. We don't translate the tile names to world space. There's no semantic for that. There's no encoding. It's just for humans to read. The first step in most of the Insomniac game's procedural workflows is to construct a point cloud from the zone data. Python scripts parse JSON from the zone files and recurse through all the references. By loading the game data into Houdini as a point cloud with attributes and flattening the transformations into world space, I can begin to reason about the game content. Point cloud data like this is also useful for generating audits. It's good for finding things like a small garden plant model with no LOD that's used 24,300 times. When I need the model assets, I can instance pack geometry onto the point cloud. It's memory efficient when the assets are built from repeated model instances. This is an incomplete list of procedural systems for Marvel's Spider-Man Miles Morales. It includes things like placing snow around the city, adding holiday decorations to buildings, adjusting geometry vertex color to drive material blends, adding navigation clues to the open world, generating imposter meshes, and counting assets and their attributes for auditing purposes. Spider-Man was set in the fall, while Spider-Man Miles Morales is set in winter. I used several procedural systems to winterize Marvel's Manhattan. Most of the objects in this Houdini network represent various workflows used to generate procedural content for Spider-Man Miles Morales. Snow was added to the open world using procedural systems. I measured the curbs and placed snow mounds on reasonable metrics while avoiding driveways and corners. Vertex colors were added to the ground to drive shader components like linear or omnidirectional blending and sidewalk icing. A similar system placed snow mounds on the lane lines. The road and curb snow are prefabs made of several model instances and built to metrics of 2 meters, 4 meters, 8 meters, and 16 meters. The final assets are gathered in a collection displayed here in the Insomniac Asset Vault. In this visualization, we'll look at a single tile in Greenwich called M35. M35 is a typical streaming tile made up of some street-level terrain with various streets and sidewalks, as well as some mid-rise buildings. Here's the data as it appears in the orbit level editor. First, I isolate the terrain. Next, I isolate the edges of curbs, and in the case of street lanes, and lane lines. I trim the isolated curves back a bit from the corners to keep things from piling up on the accessibility ramps. Next, I trim away areas near driveways or subway entrances. After measuring the resulting curves, I procedurally select appropriate elements from the collection and instance them along the curves. I use a similar system to add snow skirts around the bases of the buildings. The red spheres indicate the centroids of each line segment. I instance the different snow assets from the collection as appropriate, matching the metrics of line length to the centroid of each segment, and align them lengthwise. Looking at the level editor again, note the snow assets added to the streaming region. Holiday decorations were added to Marvel's Manhattan in a similar fashion. For example, a collection of holiday lights for various window models was hand-modeled and added to a collection. Matching the model instance names with a set of lights in the collection and picking a variant allows for procedural placement of the assets onto each candidate building. In this image, the window lights are not isolated to the single tile, so many appear floating in space. However, these belong to buildings in neighboring tiles. Vertex colors on geometry are used to drive materials and material blending. The vertex colors are visible in this GL rendering of the geometry color attributes. The red color on the sidewalks indicates where ice builds up around pedestrian paths. The yellow and green are similar blends for icy asphalt. The alpha blend at the intersection controls the directionality of the ice streaks from the road to the intersection. This video displays a tight integration between Houdini and the Insomniac level editor. Houdini on the left and the Orbit level editor on the right. Keep your eye on the intersection on the right. Note that the pattern in the intersection is omnidirectional. The streets leading up to it have some directionality caused by traffic direction. As the ground geometry with painted vertex colors is saved out to disk, the binary beta is built on the fly and ingested directly into the level editor. The video has been sped up a little bit to avoid the feeling of watching paint dry. Spider-Man Miles Morales introduces a new enemy, the Underground. These tech-powered foes jump from rooftop to rooftop, chasing Spider-Man with 3D pathfinding assisted by navigation clue markup procedurally generated in Houdini. I choose a combination of the edge markup and roof geometry to translate possible nav clues for valid jumps from roof to roof using some baseline heuristics such as vertical and horizontal minimum and maximum distance, and maximum angle using a dot product. Here's the data as it appears in the Orbit level editor. First, I extract the ledge markup. I extract the roofs and building footprints. I propagate potential candidate paths. Finally, I cull the candidate paths using additional heuristics such as distance, a ray test for collision along a path, if a nearby roof is directly above a landing point, there are separate rules for paths that go from roof to roof in the same building versus those that cross over a street or alley. Additional rules control ground to roof navigation clues. Here are the final nav clues in the level editor in purple. While the lines connecting the start and ending points make it look like some of the navigation clues are penetrating walls, there is a midpoint helper volume that allows the underground enemies to jump in an arc-like fashion. I lather, rinse, and repeat using PDG for all of the streaming tile regions in the open world. The buildings are templated, and the magenta and cyan line segments represent all of the navigation clues. The IG imposter system uses full 3D meshes rather than 2D billboards to represent distant geometry. Every building in this image is an IG imposter. Imposters represent the lowest LOD in the game. They never stream out of global resident memory. Imposters provide a fallback when high-res assets stream out of memory. We use imposters for several game systems such as cascaded shadow maps, ray tracing, and environment probes. The memory footprint of the geometry assets for Manhattan in Marvel's Spider-Man Miles Morales is about 100 megabytes. The lowest MIP of imposter textures takes up about 400 megabytes. Let's look at another building from Spider-Man's open world. This is from tile H21. The building's name is H21 Fancy Brick 0x900CB798BE9D C82D_mod. This exploded view shows all the model instances that make up the building. Buildings are constructed from model kits containing predefined assets such as windows, walls, and doors. Since the prefabricated building assets are used over and over within a building, there are a small number of unique models used per building. In this case, only 76 unique model instances. Here is the full resolution LOD of the building. There are about 150,000 polygons and 1,600 model instances. Here's the full resolution lowest LOD of the building. It's got about 90,000 polygons. In order to generate the IG imposter, I identify groups of connected geometry which shares a primitive normal. I iterate over each set of connected geometry which shares the common primitive normal. I remove shared edges from the polygons, leaving an outline of the shape. I iterate over each group of primitives which share normals and connected edges. Then I assemble them back into a single mesh for the entire building. I remove the occluded polygons, resulting in a final imposter mesh with about 5,000 triangles, having started with over 90,000 polygons. I capture the imposter geometry and generate orthogonal texture atlas images in the Insomniac engine. This is the RGB albedo atlas, the spec gloss and emission atlas, and a combined texture atlas for all of the imposters in a streaming region. Here are some examples of imposter regions composed of multiple streaming regions. Thank you very much for your time.
All right, I'm here with Patrick. Hello.
Hey, how's it going?
Good to see you. So tell us a little bit about yourself.
So, yeah, my name is Patrick McAvena. I'm one of the co-founders of Moving Pieces Interactive, which is the small game development studio based in Brooklyn, New York. We've been around for a couple years now. Our first project was a game called Dodo Peak, which is like an isometric arcade platformer, which came out on the launch of Apple Arcade and also released on Nintendo Switch last summer. And since then, we've started a new project called Shoulders of Giants, which is a roguelike set in a stylized sci-fi universe. And we've used a lot of Houdini. And yeah, I'm the primary 3D artist, Houdini user on the project too.
Cool. And what's your presentation today going to be about?
So it's about creating stylized landscapes using Houdini. So we're kind of taking a behind the scenes look at how we use the landscape system and some other tools to build levels out for our game, and also go into how we created some generators and other art assets to populate the world with.
Right on. Well, let's jump in.
Cool. Let's do it. Hi, and welcome to this presentation, Prototyping Stylized Landscapes in Houdini. My name is Patrick McAvena. I'm an artist and developer at Moving Pieces Interactive. And during this presentation, I'm going to show you a behind-the-scenes look at how we created some landscapes for our game, Shoulders of Giants. We're also going to learn some tips and tricks and a few different approaches to creating unique-looking stylized landscapes for games. A little bit about me. I'm one of the founders of Moving Pieces Interactive, a game studio based in New York City. Our first project, Dodo Peak, was a grid-based isometric platformer, and you can currently find it on Apple Arcade and Nintendo Switch. Our latest project, Shoulders of Giants, which is what we're going to be talking about today, is a roguelike set in a stylized sci-fi universe. Before working on games, I spent about a decade working as a 3D artist on commercials and advertising. Been using Houdini now for about 3 years. I consider myself an intermediate, so a lot of the techniques that I'm going to be going through today, I would say are definitely applicable to everyone, but especially if you're a beginner or an intermediate user, you're going to be able to really follow along and get a lot from these, but I hope some more advanced folks are going to learn some stuff as well. So to show you a little more about the game, I'm going to show you a teaser that we made. All right, here we go. So in terms of what we're going to cover today, we're going to kind of talk about mostly about how we use Houdini to prototype and create stylized environments, landscapes, terrains, and also a couple other things. We're going to start off by looking at the concept art for the project, and we're going to break down a few different approaches we use to create level layouts while trying to stay as true to the aesthetic of that concept art in our game world as possible. We're then going to wrap up by showing a few simple tools we created for creating additional environment art assets / generators. So in terms of project challenges and desires, as you can see on the right-hand side there is our concept art, initial concept art for the project created by our illustrator, Max. So as you can see, the concept art has a lot of different hard edges, which are difficult to achieve using like traditional high field like terrain generation techniques. 90-degree edges tend to like break down pretty quickly and can look very jagged. You could try increasing the resolution, but then you get things that are really dense, and again, it's still doesn't have the sharpest of edges that we kind of wanted to try to create. There's also a lot of negative space here, which was also going to present a little bit of a challenge. There's varying verticality that has these very sharp edges again, so things go straight up, maybe not at a slope all the time. We also knew that we wanted to use Houdini to help us generate as many useful masks as possible that we would then use in our shader system to generate foliage and other things, and also vary the color and shading of different items. The goal is to create the most flexible and easy to use system to create new levels and worlds in as well. So this is the end result of this first technique that we're going to go over here, which is pretty straightforward. It uses mostly kind of like node-based polygonal modeling, which I think if you're going to do in like a traditional 3D package would be a nightmare, but it's actually pretty flexible using Houdini's node-based workflow. One of the advantages of this technique is you can have obviously really sharp edges very easily. It's also the most precise in terms of gameplay design and level layout. You can have like a really high degree of precision. However, once you get a little more complex in terms of like laying things out, it's not the easiest to adjust sometimes. But we'll get into that a little more. We have another technique we're going to go over here in a little bit too, which kind of marries a couple different things together. So in terms of like the gist of this technique, this is a very simple kind of like early design test that we did. Yeah, it's kind of like a basic landscape. It's got a couple different mountains on it and kind of like this like sloping terrain. We wanted to see like, you know, kind of using like a very straightforward like kind of curve poly extrude method, like what we could get out of that. So starting out with the technique, we do use a height field to kind of generate just the base level of terrain. We add a little bit of noise to that. And then we convert that to polygons. And then we do a couple different things. We end up clipping the terrain, so we gotta get this like nice, like kind of chunked out piece that's not just like a flat grid. It's got some nice edges to it. We then extrude it. We do a couple different soft transforms on it to kind of slope different pieces of it. We do a poly reduce, and then we bevel it. And that's like the base kind of piece of the terrain. And then in terms of like, I think this is a little cooler part, is in terms of creating these kind of like auxiliary like side mountains, just kind of draw out a very like simple curve, and you can be like very, very loose with this stuff because, you know, we're gonna resample it, jitter the edges, and kind of use Houdini to make, you know, kind of ugly shapes more interesting. So we do that here because this is a kind of uglyish base kind of shape that we have. And then we like resample it and kind of distort the edges a bit, and then we extrude it. We also do a remesh on it. which kind of creates some like interesting like variation in the topology. We then just do a couple different soft transforms on it to kind of like blend different pieces back down into that base shape. We add a little bit of noise to it to make it look a little more mountainy and distorted. Do a poly bevel, and then we extrude it again to kind of blend it into our landscape. So here it is blended, and then we just basically use the same technique for the mountain just to the right of it. And we do another remesh, which kind of actually does a nice job of like blending everything together, and kind of gets rid of these like a lot of like transitional lines where you kind of have two pieces of geo that look like they've just been placed together. This kind of smooths things out actually pretty nicely. We just do a couple different like cleanup operations. We remesh everything, like I said, bevel it again, and then, as I was saying, we kind of wanted to use Houdini to just make some like simple vertex colors that we could use to as masks in our shading system in Unreal. So we're basically just creating some groups based on normals and curvature, and applying some vertex color to those faces. And then this is the kind of final result of our first experiment that we did. One very important thing is if you ever try to bring in vertex color information into Unreal, it's very easy to like forget that information has to be on the vertices and not the primitives. So if you're ever like, why is my vertex color information not coming in, just make sure you can always do like an attribute promote if for whatever reason you're doing color information on primitives, which I was actually to get this kind of look that I wanted. But yeah, just throw in an attribute promote and you're good. Just change it over to vertices. So getting a little more complex with this same technique, this is kind of like another version where it's, as you can see, it's a little more complicated, have a couple different like land masses in there, basically using the same approach. We kind of have very loose curve that we're remeshing and resampling, extruding to make a more interesting base shape, which you can see here. Adding a little bit of noise again, and then we basically go in and we just kind of repeat this process for all the different like land masses that we want, and then we can do a couple different like booleans to kind of like cut things out and create some like nice negative shapes, or sorry, negative space in the shape. We layer everything together again, and we remesh it all, and we use that same technique where we add a little bit of vertex color for our shading system in Unreal. And this approach, I think it's the strongest part of it is you can get really high degree of precision and you can get really nice like hard edges, but it's not the most flexible approach in terms of like if you want to create more complicated levels and like landscapes. So we kind of wanted to like iterate that a little more, and we wanted to try to find a technique that was a little more simple and straightforward and streamlined. So I think the approach that we're going to use moving forward is this next one that we're going to get into here, which is basically using a mix of height fields and polygons in certain areas based on the height field information. And I think this is a little bit more like flexible approach. As you can see here, this is like the end result in engine, a level from our game using this approach. So getting into it here. This is like the end result in Houdini. We got our base kind of like height field, and we have like a playable area, which is kind of like this like yellow area here. And the way that we created that playable area is like a couple different ways you could do it. You basically just want to mask, right? And you want to use that mask to kind of have it, however you want your kind of playable area to be, more like flat, etc. So we used just a simple sphere and then a mountain stop to kind of distort it. But you could also use like a Photoshop to like draw out some like interesting shapes, which we've also done, and import that and use that as a mask. So yeah, basically you're using this mask and you're basically just layering on a bunch of different height field noises to get the look that you want. So here's kind of our, we got these kind of sharpy edge kind of mountains and this kind of like a big kind of like playable area in the center, kind of like a big canyon going on. And then it's, if you want to create some like interesting things going on, like here we have this kind of ravine that like separates like the different areas. We basically just drew out a curve and used a poly wire, and we do a mask by object. We basically project like, basically you get a mask back on your height field. Then we use some noise to kind of like shift that down to create that ravine, which is cool, but like you can see that it's got some like very jagged edges going on. So what we then do is we use the height field and we use that same piece of geometry we used to create the mask with. And we basically extract part of the height field, cut it out, turn it into a polygon, and then we clean it up. So then you can have, it doesn't have those like really sharp kind of ugly edges. And then we just kind of use this piece on top of the height field, and it ends up working pretty good. And then we can just kind of reuse this approach if we want to do a lot of different operations. So it's kind of like a mix of polygons and also, height fields. So we have this kind of like hero piece of terrain here as well, using the same kind of technique. Basically, just like drew out a curve to get a shape, extruded it, and then mask by object, and we cut it out from the height field, and then basically just convert that back into a polygon, and we use another mask to kind of like pull back this piece to kind of slope it down. You could also do like a soft transform if you want as well. So this like blends very, very nicely with the height field, and also you can get those really nice sharp edges that we wanted for our game. That for us, this works really well. So the next thing that that we want is, again, we wanted Houdini to kind of generate a lot of different layers that we could use as masks in our shading system, and also to generate and place foliage in Unreal. So we just use a very simple height field erode node, and we sim it out a little bit, but instead of applying it to the actual like height, we just use it as basically we use a bunch of copy stamps to use the layers, and we export those layers into our HDA. But we don't, I think if we applied it directly to the terrain itself, to the height information, it would be too realistic for us, and we want something that's a bit more stylized. So again, just using those layers, we ended up creating a couple other layers just using like mask by feature. So here it's just like curvatures. We got these nice outlines that we use. Just different options for you that you can bring into Unreal to do different shaders and effects and colors and all that stuff. So yeah, just kind of using different layers and subtracting them, masking them out, and then kind of cleaning them up and merging them back into the end result, which is this guy here. So we got a couple different layers here that we're going to bring back into Unreal. So this is the end result in the engine. You can see we've just used all those different layers and masks to create different looks for different environments. Got rock, we got kind of this like dirt ground shading, and then also one aspect of our game is you bring back like light to like a dark world. So we kind of have two different looks for every world. So here it is, kind of in the light variation of that, and you can see we've used all of those layers that we generated in Houdini to generate in Unreal different foliage in different areas. So that's very powerful. Not having to paint the foliage by hand saves a lot of time. So that's definitely a very cool technique to explore. So yeah, we still have a lot more exploration we're going to do in terms of like building out our tools more. We're definitely going to expose some parameters and and the HDA and Unreal that's going to allow like level designers to more easily make things and not have to just rely on myself, the Houdini artist. So next in the presentation, that kind of sums up our like behind the scenes look in terms of how we used Houdini to prototype our look for our kind of overall base terrains for our levels. Now we're going to go into some different tools and generators that we made to make stylized like sci-fi assets to populate the world with. So the first thing that we're going to go over is this kind of like sci-fi like space station debris kind of generator. If you ever look at any like sci-fi art, they always have these like really cool looking like rings, deconstructed like space station kind of stuff. So we wanted to make something that could generate that easily in Houdini. And this is the asset here, and it's pretty straightforward to do. You just kind of take any base shape you want. In our case, it's a torus. We remesh it to get the kind of desired density we want. And then we branch off to make the kind of like trellis effect. We basically create a group from the edges of the torus. And then we take that edge group and we convert it into curves. And then we add a polywire to create that like trellis effect. And then, as you can see here, some of these faces are kind of like the higher up we go, the more deleted these primitives are. So to do that, we have two different primitive SOPs. Or sorry, primitive wrangles, bad. So the first one basically takes, basically create an attribute called the Y position. And the higher it is, the closer to 1 it is, the lower it is, the closer to 0 it is. So we basically take the height, maximum height, we fit it to a range of 0 to 1. We store that as an attribute. And then we have our next primitive, or sorry, point wrangle. We basically go through and using that, we use the random number generated using a seed from the PTNum. We use that like Y position and we multiply that by the random number. So that basically has greater odds for the primitive to get deleted the higher it is. And then the lower odds are, it's less chance for it to get deleted towards the bottom. So we actually kind of use like a 0.5 as like a cutoff. So anything above 0.5 is going to increasingly higher chance to get deleted. And then below 0.5, it is not going to get deleted. We just kind of loop through that, delete some faces, kind of merge it back together and add some normals. And then we just have a nice shape that we use to Boolean out part of it to kind of make part of it look like it was like chipped off or missing. We just kind of clean it up and yeah, you're good to go. And again, you could use this, you could plug in any kind of shape you want and you can kind of get this nice like broken up like space station kind of look. So the next thing we're going to go over are creating some like stylized cliffs. So this is the end result of what we did, and I've got to get a shout out to CG Monkey King for the copy and stamp technique that we're going to go into here. So the first thing that you want to do is you want to create your base shape. In our case, we're just using like a pyramid. Get a nice scale that you want. We're going to remesh it to the kind of desired like density that we want. We're going to use a mountain SOP to distort it a bit, get a little more interesting kind of shape in there. We're going to add some normals and transform it up a bit to get a nice elongated kind of jagged rock. So the next thing we're going to do is we're going to create basically a series of points that we can copy this to. So we're going to create a box and we're going to use a point from volume, and we're going to basically get up points inside that volume. We're going to add an attribute called PTNum, and that we're going to use as a seed for this copy and stamp node. And basically the idea is to use this copy stamp to basically get some random rotation and random scale to copy all these pieces back to. So basically have a transform right before we pipe into the copy stamp that just has like a basic fit operation with a range on it. And we're using that myID as a seed, and we just randomize the scale and rotation, and we copy it back till we get something like this. Then to get a little more detail in there, the next thing we do is I'm just kind of combining it and cleaning it up and remeshing it, adding a little nice bevel to it. But then we actually convert it to a volume, and we add a volume sop and some basic noise to it to get the look that we wanted. We convert it back to polys, add some normals, do a poly reduce, and we get our final result. So the last thing we're going to go over is creating some stylized rocks. So I got to give a shout out to IndiePixel for this chipping technique that I'm about to show you. So here is the final result of what we're going to go through. So you can start out with any base shape that you want. In this case, we're using a sphere. Kind of modifying it a bit to get the look that we want. Transforming it, and then the really cool thing about this technique is we add some normals in, so we have normals. We use a for loop, and we're going to use a clipping node inside of that loop, and it's going to take the position of the normal and the orientation, and it's going to loop through and basically chip off the edges to kind of give this really cool like chipped rock look. So we basically, inside of this clip node and the origin, we're going to use the position and the normals, and then also for the direction, the same thing. And then we're going to add in a polyfill to fill in those like chipped areas. And we're going to end up with a cool shape like this. You can see all the chipping that this is done. It's going to do that for every point. And then after we do that, we're basically just going to run it through a little cleanup process, some remeshing, adding back in some normals, a bevel, and in our case, we're going to subdivide it and then poly reduce it. And then, yeah, this is what we end up with. And this is a really cool, super powerful technique you can use on a lot of different types of assets to give this kind of like stylized chip look. You could also add, more noise and further refine it if you also want to go for like a more of a photoreal look as well. So that concludes this presentation. I want to thank Houdini for having me and letting me show what we've been up to everyone here. And if you guys want to learn more about me or follow what I've been doing, it's just Twitter is Pale Blue Motion. And then if you want to follow the progress of our game, Shoulders of Giants, that's twitter.com/shouldersofg. And also the website for the game is movingpieces.io/SOG. Thanks, everybody. Hope you enjoyed this. Take care.
All right, I'm here with Paul and Mai, two guys from the SideFX technical consulting team. Hey, guys.
Hi, my name is Paul Ambrosiussen. I'm a technical artist as well as the labs lead at SideFX. Today we'll be talking about SideFXLabs.
My name is Miguel. I'm a new member of the SideFXLabs team and also a technical artist. Before this, I was working in production doing simulations, effects, and shader work.
Right on. What are you going to be talking about today?
So our presentation has been split in two. In the first half, I'll be talking about various little enhancements that we've made, such as user experience to HIP organization to new little tools in tops as well as other contexts. And then in the second half, Mai will be taking over to show some other really great big updates that he's been working on.
So in my half, I'll be covering a new update to our vertex animation toolsets that comes with new features that improve the visual fidelity as well as make your workflow easier and more ability to customize our tools. And I will also be talking about new poly reduction tools that's suited for character generation, as well as collision generation, and just some day-to-day easy-to-use life improvement tools for you guys.
Right on. Well, sounds awesome. Let's jump in.
Hi everyone, my name is Ambrosiussen, and today me and my colleague Mai are going to talk about new and improved workflows for artists, which is essentially an update to SideFXLabs that we've done over the past half a year since the last presentation. This is also Mai's first presentation about labs in public, since Mai has joined the team at SideFXLabs, so please everyone give Mai a welcome. So let's get started. So the presentation has been split up in 3 parts on the first half. First of all, I'm going to talk about some user experience enhancements we've made to the toolset. Then we'll be talking about some new additions to the tools. We'll be looking at an update to some tools. And then I'll be handing it over to Mai, who'll be showing you some really cool and awesome stuff that he's been working on. All right, so let's get started. So to begin with, something that we've added some time ago is something called the sticker picker. And the sticker picker is essentially a tool that allows you to drop down images in your network editor in a very easy and convenient way. So as you can see, we ship a variety of stickers by default that you can just place in your network editor just by double-clicking on it in this interface. It is not new functionality. People have been able to do this using the network editor images functionality that's been in Houdini for a really long time. But this is a really nice, easy way, sort of an interface around this functionality so that you can drop down those stickers and work with them with ease. So since these are network images, you can use all of the default functionality that the network images have, such as controlling opacity. You can delete them, you can attach them to nodes, and much more. Another thing that we've added is the ability of painting in the network editor. So if you, once again, click on the Labs menu and click on Paint, you now get a little paint cursor that allows you to paint in the network. So once again, let's take a look at some more functionality up there. You can, of course, change the size of your brush. When you press I, you can sample any color that is found in the network editor to sort of change the color of your brush. So in this case, that allows me to write some differently colored letters. So what would you use this for? Well, that's a good question. You could use this for annotations. You could use this to draw some arrows on things. And you can just use it for a whole lot of things and just make your network editor a lot more visual and pretty in general. Once again, those are also just network editor images, so you have the exact same functionality as the stickers. You can attach them to nodes, you can delete them, you can control the opacity, and much more. Continuing on the trend of colors, we also added the ability to sample screen colors for colored ramps. All you really have to do is just right-click on a color ramp and click the sample screen colors, and that will allow you to sample a color on any screen that is turned on your computer. So right now I'm just doing it on Spotify that I had running in the background. But really what you could do is you could sample from a second screen that you have open for reference and much more. So this functionality is very similar to what you'd, for example, have in Substance and is useful for example, coloring terrains, coloring geometry, or just generally making a ramp hold random colors that you can use for any other purpose. So this is a really cool example of a use case for this functionality. You can open up Google Maps or Google Earth, find the location that you want, and then just sample those colors and use them on a height field. All you really have to do is use some grayscale value as a lookup for the ramp, and then just assign that as a color. So in this case, I'm just using height field visualize, and that allows me to create these really, really pretty colors straight right there inside of Houdini. Next up, new tool. So we added the ability to do booleans on curves. This is something that we found ourselves doing quite frequently. Previously, you'd do this using the intersection analysis and intersection sketch and then some wrangles and some grouping. But since it's a workflow that you do quite often, we figured why not just add it as a tool in Labs. So as you can see, there are a couple different modes. We have the intersect ability, which is going to give you the intersection. It can give you the subtraction. So it can subtract a box from, for example, curves, or shatter, which is just going to cut up your curves based on the intersection with the polygonal object that is fed into the second input of the tool. Next up, continuing on the UX trend. So HDAs are a major part of Houdini, right? We all make them, we all use them, but it's quite difficult to create them, maintain them, and it's especially difficult to increase versions of HDAs, right? So let's say you're working with an edge damage tool, right? You did some work on it and you want to increase the version of it. So now you want to have a version 2 of this tool. What would you do? Well, first of all, you'd find your subnet or your HDA, you'd open the asset manager, you'd press duplicate, you'd rename the tool, and you'd hit save. But the problem there is that it would not have any of the changes that you've made in your network editor when you duplicated the tool, right? The changes you'd made would either have to be baked into the version 1 that you had, which then would also go to version 2, which is not what you want. When creating an HDA, you'd have your subnet, you'd say asset, create new digital asset from node, you'd get this little menu here where you can set the operator name, operator label, and where to save it. You'd save it, and then you'd have to go to the type properties window and change a lot of properties here, such as icon, tab menu, inputs, and all things like that. So in general, it works, it's acceptable, but it's difficult UX. So what we wanted to do is we wanted to make that a lot easier. So we introduced something called version digital assets. What that allowed you to do is it just very easily wrapped up that HDA workflow into a single menu, or 2 menus actually. You just right click your node, which can be a subnet or an already existing HDA. You go to version digital asset, you click save as, and that brings up this window here that allows you to create a digital asset out of it. You just control the type, you're able to specify the user namespace or the branch namespace or both if you wanted to. You can set the version. And the nice thing about this is that if you were to save as on a node that already exists, it would know that there is a version 1 already, and therefore it would give you a namespace that does not conflict with any other node that you have loaded in your environment currently. You can set the label, you can set the tab menu entry, set the safe path, and all of these, of course, have drop downs so that you can see what is already there, making it a lot easier for you. We also have a preferences window, which allows you to control some of the preferences that this window will use by default. So you can, for example, set the default user namespace. You can set the custom branch namespaces. You can control whether or not the branch should be put in the label of the tool by default. You can set default menu entry. So if you know that you're always going to create tools that have to be in a specific tab menu for your studio, for example, you're going to set the default one right here. Additionally, it also has some other things that you might want to be setting by default, such as the save location and these other toggles. So just give it a try, and you'll see that it'll be a lot easier to use, create, and manage HGAs in general. Additionally, we're also happy to say that all of the labs tools are now fully Python 3 compatible. They have been for a little while, but we've been doing additional tests to make sure that they actually are. And so far, our tests have returned positive. So according to the VFX Reference Platform 2021, we are fully compliant. Then another new tool that we added. So we added the extract image metadata top node, right? So since we're all getting more into tops, a thing that we figured was very useful is the ability to extract metadata from images. So think of this use case. You have a bunch of images on disk, and you would like to know how many of those images have a specific resolution, or how many of those images are larger than a specific resolution, or you'd like to filter out all of the images that are using a specific color model or have a specific bit depth or number of channels, right? Find all of the images that do not have an alpha channel, or find all the images that do have an alpha channel. Well, this node very easily takes in input images from, for example, a file pattern, and processes those using IInfo, and gives you all of this information as metadata. Very convenient. Next up, another top tool, we added the concatenate text node. So this is very useful if, for example, you have a file pattern node or some other node, like for example, the filter by state node that creates a bunch of logs using or containing errors of work items that you had upstream. You would get tons of text files on disk that, ideally you'd want to have in a single text file so that you can print it out in a log and send it to someone through an email, for example. Well, this node just takes all of those text files and concatenates them into a single text file. You have the ability to control a couple of things. The most important one probably is this new line each input, and that just makes sure that every single input gets put on a new line. So if you have an alinea of text or a paragraph of text here and a paragraph of text here, you probably want to make sure that those are not directly attached behind each other, which in this case would be testing 1111, testing 2222. Well, in this case, you just split it into a new line. Next up, another really cool tool. This tool was made by Simon and added to Labs. It's called Labs Edge Damage, and it literally just does what the name says. It adds edge damage to your geometry. So, for example, you can create this low poly geometry here, and you want to make it look old, you want to make it look worn out. Well, you just plug it in and you have it process, and it gives you something that looks nicely detailed like that. You have control over the amount of damage that you want to sort of make it worn out at a specific stage. You have the ability over 3 different modes of adding edge damage to your geometry. You can use a VDB route, which will convert this to VDB and use noises to add detail. Or additionally, you can use the Boolean mode, which is going to use Boolean methods to Boolean out these edge damages. The nice thing about this mode is that you'll preserve a lot of the original topology, which is what you'd lose with the VDB route because you're creating a completely new set of topology. And then the last one is color, which is essentially the same as the Boolean mode, with the difference that it does not actually do a Boolean of your geometry, but it actually just adds vertex colors to the edges of where the damage would be. So this is, for example, useful for creating masks that you'd want to use for baking or for any sort of shader operations that you might want to do in your game. This image here is the same. This pillar here is the same as this one, with the exception that we just added some color to make it look more old. All right, next up, another really cool content creation tool that we added recently, which is the simple rope wrap. It's, once again, a very simple tool. All it really does is it just wraps some ropes around an object. So let's say that we have this pig head object here, and we plug in some grids into the simple rope wrap. It would then use the cutting surface of the surfaces to cut essentially a ring around the object and use that to create ropes with it. You can control the thickness of the ropes, you can control the rope profile, you can even have it be simulated to get a more organic looking result, and it produces UVs and everything else that you need for a rope as well. It does poly reducing as well, giving you the ability to create a nice game-ready rope that you can just import into your game engine. This tool also works in Houdini engine. So if you, for example, want to use this tool inside of Unity, inside of Unreal, inside of Maya, inside of 3ds Max, you can just import that tool in those Houdini engine plugins, and it will work there as well. Then another really useful tool that we often use has to do with baking. So we've had the Maps Baker for a long time, which is a really great tool of extracting attribute data into textures. But we wanted a more procedural method as well. Procedural in the way that it is live and you're able to use those textures without actually having to bake them to disk. Well, that's why we created this attribute import cop. And what that does, it essentially uses the same technology that the Maps Baker does, with the difference that this is a cop node that is live and does not bake things to disk. So you could use this to, for example, do any sort of shader operations inside of Houdini using a cop node as input. You could do other compositing operations inside of cops itself, and just do crazy stuff with it. The nice thing is that it uses an attribute to do the sampling with. By default, of course, that is the UV attribute. But if you want to use, for example, a second UV channel or a third UV channel or any other type of attribute that should be considered UVs, you can just change it there. You can set the attribute per channels that you want it to sample. So in this case, by default, as you saw in this video here, it is going to put the vertex color into the RGB channels. And then you could, for example, stick some additional data into the alpha channel, for example, P-scale or alpha or anything else that you might have. Next up, calculating UV distortion. So Houdini has had the functionality to show the amount of UV distortion on your UVs and on your geometry for quite a while. You were able to access those using visualizers. But the downside of those visualizers is that there was no way to really sample those visualizers' values as attributes. So what we've done is we've taken the same source code that calculated the values for the visualizer and put it in a node itself. And we just wrote the same algorithm in Vex. And that gives you this UV distortion primitive attribute value that you could use to, for example, insert additional seams, because you now know how much distortion there is. Or you could use this for example, control the UV layout with it, right? So you might want to take the shells that have a high number of distortion or a high number of stretch and just modify the amount of texel density that it's going to get in the UV layout. So now that we have the ability to calculate the UV distortion, we wanted to push it a little bit further. We wanted to find a way to automatically reduce the UV distortion based on those attribute values that we calculated. So we added this tool called Remove UV Distortion. And what it does is it basically finds shells with high numbers of distortion, right? So for example, this pocket of distortion here, and it has the ability to remove the distortion there by inserting new seams iteratively. So it does essentially a feedback loop where it tries to remove distortion over and over and over while making sure that it doesn't introduce any new distortion. So what you might notice in this image here is that this UV unwrap that I did, which was a really poor quality, which I did on purpose, by the way, you see that we have UV shells that are essentially tubes, right? So these legs here have been unwrapped as tubes. And the problem with tubes is that you have these internal loops, right, inside of this UV shell, where the internal loop could, for example, be the bottom of the pants, so to speak, and the outside loop would be the top of the pants here, right, of the tube. And because there is no seam between the top and the bottom of that tube, you will have a high level of distortion because you're essentially flattening a tube, right? And so what the Remove UV Distortion tool has the ability to do is create a seam between those two nested loops and flatten it again. And once we do that, we can see that we've now removed the UV distortion here around the legs. So that's one of the modes of the Remove UV Distortion. But as you can see, we still have pockets of UV distortion that we want to remove even more. So that's what the tool can do as well, by just increasing the number of iterations and setting it to remove hot pockets of UV distortion. And when we do that, we can see that we've reduced the UV distortion even more. And there you go. So we've taken some UV shells that originally were quite distorted, and we've removed most of that distortion. So especially this shell here, you can sort of see what the tool does is it finds the outside boundary of the UV shell, and it finds the highest level of distortion inside of the UV shell, and it tries to insert a seam going from the pocket of distortion out all the way to the boundary. And once you flatten that, you can see that you sort of get this unwrapping sort of origami-like effect happening. So if you go back here, we can see that these are all round, right? There is no sort of internal cuts. But when we go back to the last image, we can see that it inserted those nice cuts here. And so that's that tool. Give it a try and let us know what you think. We've tested it on a large variety of meshes and it performs quite well. The only thing that the tool doesn't handle quite elegantly yet is the ability to remove stretch, right? It's doing a really good job at removing compression wherever possible. So in this case, this is an area that you wouldn't really be able to remove any distortion on. But hot pockets like these, for example, it does really, really well. But the stretch is something that is a lot harder to do, and therefore the tool doesn't quite do that well enough yet. But that's something that we're looking into. But please provide us with any feedback you might have. Next up, we have the skinning converter sub. So this is a tool that has been in labs for a long time, but it used the old way of rigging and skinning inside of Houdini. So what we've done now is we've updated the tool to use KinFX. So the output of the skinning converter is no longer an object level rig, but it is now an actual KinFX compatible geometry, skeleton, and animated skeleton. So in this case, you can see the first input is just your bind pose. The second one is your rest pose. And then the last one is just your animated skeleton. So in this case, with KinFX, that's just a set of primitives and points. And if you plug that into the bone deform, you now have your same footex animation that you had before, now actually rigged and skinned and deformed using a skeleton. So the input of the skinning converter is something that you would not be able to bring into a game engine without methods such as skinning or footex animation textures, but the bottom approach actually gives you a skeletal mesh that you can import into Unreal, Unity, or any other game engine that supports skinned meshes. Yeah, so that's that. That's the tool. That's my half of the talk, and I'd like to hand it over to Mai now. Thank you.
Welcome to the second part of our talk. My name is Mai. I'm very excited to meet you folks. Let's dive right into Vertex Animation 3.0, which is a big update since Vertex Animation 2.1. Some of the goals we are hoping to achieve with this update is to streamline the user workflow as well as adding more powerful features. So we started with redesign the user interface on the Houdini side as well as the Unreal side. In the Houdini side, you basically will follow a top to bottom and left to right workflow. And the number of parameters and options are not necessarily fewer than the previous version, but what changed is that you don't need to do many manual work just to get the thing to work. It's very easy to just use default settings to make the tool work, but the new options are extended features for you to customize and do more advanced things. Here on the Unreal side, as you can see here, we got a new interface as well. And a big thing that we got rid of is the list of real-time data that you need to previously input just to get the Vertex animation to work. As you can see in the parameter interface, most of the stuff you've got here is just static parameter switches and used to enable or disable features. You don't have to type a lot of numbers. You just input the textures and the tool should work. So where did that data go? The solution we found is to use two little triangles, as you've seen here in the image, pointed by the yellow arrows. Those two triangles basically situated at the boundaries of your simulation. And the list information such as the frame number, the padding ratios, and all that stuff are encoded in the positional data of those two triangles. An additional benefit is that because those triangles define the edge of your simulation, now you don't have to worry about the vertex animation get accidentally frustum called when you don't intend to, when you just pan the camera away and the vertex is not in view anymore. The new bounds ensures that whenever you need to see anything from your vertex animation, the camera will always detect it. We also kept the original right-click menu scripted action options. We actually added a few more. Now you have the action to set HDR textures as well as non-HDR textures. You do have the legacy support to use the data table, which comes in handy if you want to use instancing with the vertex animation static meshes. It's also useful if your simulation is quite large in terms of the size. Then using the data table's numbers can sometimes provide you with slightly more accurate result. So it's an option there for you to choose. One of the big things we need to fix is the rigid mode first frame crack problem. That just related to the pivot accuracy. So on the top left, you will see the 2.1 version, and to the right is the after, which is the 3.0 version. As you can see, most of the cracks are gone from the first frame. We used several encoding methods. The blue and red image shows you how the shader will dynamically pick which encoding method is better. So one of the method, the blue one, is instead of using vertex color, we're using two UV channels to store the pivot position, and each UV channel has a 16-bit depth, so that's a lot better than the vertex color's 8-bit precision. The red one is a more advanced version where we did a lot of bitwise manipulation to just preserve even higher accuracy while still using 16-bit UV channels. As you can see, most of the pieces actually ended up using the red encoding method, because in the Houdini side, when the node cooks, it will dynamically evaluate which piece should use which encoding method that should give you a better result. And that information should carry over to the shader, so the shader can pick how to decode that accordingly. At the bottom, you can see two of our three accuracy modes. So the left one is the high accuracy mode, and the right one is very high. There's a slight difference here, as you can probably see. And we also have a third version, which is the maximum. With the maximum accuracy uses 32-bit instead of 16-bit. that is more memory intensive, sometimes resulting in slower calculation speed. And I didn't show that because the visual is using this example, there's barely any noticeable difference between the very high and the maximum. So I do recommend you just stick with very high because it's faster and it's cheaper. The pivot accuracy improvement does not only relate to the first frame, it actually improves the accuracy of the animation throughout the whole the duration. So I did a lot of aggressive testing during my development. As you can see here, what I tried to do here is using the green version, which is exported static mesh version of a particular floating frame. It's not even integer frame, so it's like something like 121.4 frame, and we compare that against the colored version, the multicolored version, which is the vertex animation version. And I was so glad to see so many Z fighting. That means the accuracy is pretty good. Another thing that's added is the interpolation for rigid pieces. So this video, what you see here, is what you would get if you export a fast-moving animation and play at a slow frame rate using the 2.1 version. Basically, there's no interpolation. So the standard interpolation for rotation is called SLUB, which stands for spherical linear interpolation. This video demonstrates a limitation for SLUB because the algorithm needs to figure out in which direction you need to rotate. Since between two orientations in adjacent frames, there's basically two ways in 3D space to rotate from this frame's position to the next frame. You can go one way and you can go the complete opposite direction. And the standard SLUB needs to limit the rotation to under 180 degrees. So they always pick the shorter path, just for safety. Otherwise, you get confused about which direction to turn from frame to frame. You can see the problem here because I color-coded the pieces based on the rotation speed. So the redder they get, they should be spinning faster. But what we see here is the red pieces and the blue piece and purple pieces basically are spinning like a similar speed because every piece is limited to only 180 degrees of rotation per frame. So if you're going higher than that, there's no way to correctly interpolate using the standard SLUB. And you can see some pieces start to go in the wrong direction as they are increasing their speed. So the solution we ended up using is a unique method called, I termed it the multi-RPF SLUB, which stands for multi-revolutions per frame. It supports much higher than 180 degree of rotation. You can basically go several cycles per integer frame. So you can literally go to thousands of degrees per rotation. The advantage of that is now you don't have to worry about how fast your pieces are spinning. You can just use our new tool to export your animation, and you can play your animation in shader at a much slower speed. You still get pretty accurate and smooth rotation. This method uses the angular velocity as assistant for us to help decide which way the pieces should be spinning and how fast they should be spinning. But there is more. As you can see here, this is using the multi-RPF SLUB. This simulation here is sort of like a rock cyclone, could be like a cool magical effect. Just a bunch of rocks rotating around in a tornado formation. And because there's such a gap between the exported frames, you can see that pieces are actually contracting. The contraction is a reflection of the pieces trying to go from frame to frame position in a straight line, where in actuality they're supposed to be going in a circle. So what we want to achieve is to somehow find a way to reconstruct the curved trajectory based on limited frame information. So we could do that using acceleration. So the VATROP now can support internally compute acceleration and export that through the color texture. Now you can pick that up from the shader side and use the acceleration to help you compute the original curved trajectory. So this is a much better result. And this video shows the sort of the comparison between the smooth version and the contracting version. Now if you compare this, which is all the interpolation turned on, against this version playing at the same speed with interpolation turned off, and you can see this is basically unusable because there's such a time gap between each frames. as this animation is basically playing at 5% of its export speed. Now, this opens up the opportunity for you to basically run your simulation, then export through that using a much lower frame rate, and just turn on interpolation on the real-time side. So this saves your texture memory because there's less pieces and less time you need to export. And you will still get smooth interpolation in your game. Another thing we added is the support for tangent space normal map, which is a feature that's missing from the previous versions. In order to support that, basically we need to add tangent data to the shader as well as the normal data. Because with just the normal data, your tangent space normal map can essentially spin around the normal vector. There's another degree of freedom that needs to be controlled. So we swapped out the original normal map export into basically every mode is using the rotation texture, because rotation texture is a more compact form of storing both the tangent information as well as the normal information as just the quaternion, because the quaternion can describe both degrees of freedom simultaneously using just 4 texture channels instead of 6. And that get decoded on the shader side, and you can apply your artist authored surface normal to the result of the vertex animation rotation, either per piece or per point. So on the left side is a vertex animation version, and on the right side is just a static mesh version, and you can see the result is pretty much identical. Now, that is not limited to soft. We basically have blanket support for tangent and normal map for all modes, including fluid. For fluid, that means we're also providing native support for UVing. There are 2 ways to handle UV. It's better to determine yourself how you want to UV your fluid, and you just send the UV data to the channels that we offered as options, and that will be sent to the shader, and the shader can decode it and apply the textures. So you can get your normal map as well as other just textures onto your fluid mesh. Fluid is also not just limited to actually fluid type of animation. It's basically a dynamically remeshing. So I kind of slightly renamed the mode. It's just called dynamic remesh. You can basically get any mesh into the shader using fluid mode. One additional advantage is that fluid mode has a very good preservation of the original normals you signed. With soft mode, you need to make hard edges duplicated points so that each point can have unique vertex data, vertex normal data. For fluid mode, because we're basically assembling triangles, therefore you can export smoothly shaded versions like this one, or you can export very harshly shaded like a font and turn into a geometry with like hard edges at the edge of the font. That works as well. We try to strike a balance between ease of use as well as extendability, because that's a lot of times people are requesting that to have more ability to do things with that. So don't let this intimidate you in any way. So the essence is that if you just need normal usage of that, you can just hook up some of the standard outputs or use the standard parameters, and that will get the job done. But most of the additional long list of parameters and outputs here are for you to extend things in your own way and make cool and crazy stuff happen. We have provided very detailed tooltips and some explanations for everything from the parameters in VAT, as well as all the parameters in the shader and all the material functions. So you just need to hover your cursor over them and see what they do and how to use each of the options in relation to other options. So one of the examples here is to do a customization with the rigid mode. So this is actually a rigid mode, but you can see the pieces are stretching because we are stretching the pieces by their velocity. We exported the velocity to the cloud texture. Now we can use the velocity to fake basically like a motion blur effect. In animation, this is sometimes deployed to create this illusion of a motion blur. It also kind of looks like a soft body, even though it's a rigid body. Another thing we could do with the particle mode is now we support more features that comes with standard particle systems. So we can have scale by velocity and align the orientation of the particles along its trajectory, as well as adding just custom rotation or per particle randomness. We also ship additional material functions such as transform velocity or computer-based randomness that you can use it together with the VAT functions to achieve some of this additional results. We didn't hard code everything because some of that implementation needs to be flexible. So a lot of this will be covered in upcoming tutorials that will go into details of how to use these features. Another thing we added for the particle mode is instead of just a square card, now you have a default option of square, triangle, as well as hexagon cards that can help you prevent overshading or overdraw better. And especially if your visible particle is in some sort of circular shape, then you might not need to use a square. It might be more efficient to use a triangle or hexagon. We also added custom shapes, so you could literally just hand draw a curve, and that ROP will turn the curve into a custom card that get exported that you can use in the shader. And you can even include multiple cards. So this is a single static mesh, but just use different shape IDs. You can identify and differentiate different shapes and assign different weight, and that controls the distribution between them. So here I had a little fun, put together some of demos for you guys to showcase the new VAT ROP's capability. One thing I'm trying to do here is basically to push the limit of our tool using some almost film level assets with sometimes hundreds and thousands of pieces of vertices. But the idea is to really see how high is the ceiling of our quality. Then from there we could go on to optimize and make smart decisions about the trade-off between the visual quality you want to hit against the performance you can afford based on your game, based on your platform that you're using. Credits to the kind people who provided me with the asset, the simulations. So this is the soft mode. The previous one is a fluid mode. This one is also an asset with the film level of density, essentially. But it was a lot of fun. This whole thing is actually 3 different assets put together, but you don't see the sims between them because they align pretty accurately together. This is a particle sim I did against a background from the Epic Games environment. This showcases the new particle VAT mode's ability of using basically the scale by velocity, as well as the color export, and basically a lot of extendability using utilizing the power of Houdini's pop sim and volume sim. So in this example, I used a volume sim to drive the particle sim to get a more fluid like motion. Here's another film asset example. There is probably hundreds and thousands of pieces here. Maybe even hit a million pieces. I don't quite remember, but it's basically multiple assets put together, and they merge together pretty seamlessly. In this illustration, it showcases the difference between the wood pieces as well as the concrete and glass pieces. So this is also with interpolation turned on, so we can get smooth motions. Personally, I loved this video when I put it together. What I did here is essentially it's the same exported rigid body animation, but I slowed down the time so much it almost looks like it's frozen, but it's like still slowly moving. And you can see some of the pieces in front of you are still spinning, whereas the pieces at the back are almost like stationary. That means the piece at the front is spinning very fast, and we can accurately support that. The frame rate that this particular recording was playing at is 50 times the exported frame rate. So just shows you now you can do so much with a limited amount of export. Speaking of effects, we also did an update on particle systems. So we upgraded our make loop tool to 2.1. In 2.1, one of the major things that we did is to support the tool properly for Niagara particle systems. Basically, we need to do some manipulation of the particle ID, age, and life attribute to make Niagara system read the particles properly, so that they can loop and interpolate correctly. So once that's figured out, it's very easy to use the tool itself. You can just create a particle sim and drop down make loop, and it will create the loops for you. Then you can just port it seamlessly to through our Niagara ROP to Niagara system. We also upgraded the volume blend. Previously, the volume doesn't blend very well if you have dynamically resized volumes. Now that's properly supported. And here I'm testing it with the high-res volume, and the result is pretty satisfactory. On the subject of particle sims, smoke sims, one thing that's pretty useful in a day-to-day life is to have some basic tools that control things such as the random directions. So I created a random direction node. It's not very technically sophisticated, but it's one of those quality of life tools that help to speed up your workflow. So here are some of its abilities. You can do basically pure random direction, or you can do directions that's radiating from a reference geometry or reference point, or you can radiate directions from a reference axis, or from a curve, or something like a closest position on a reference geometry. That's basically the same thing as curve. You just pick the closest position and radiate from there. The square example uses the closest point on the reference geometry, so all the arrows are pointing from the corners of the cube. Then we also have two directions, where you can control the distribution between the two directions randomly. Here's another companion tool, which I call the random selection, which gives you some quick and artist-friendly way to select randomly or in a periodic way. You can do periodics with constant intervals, or you can do random intervals, where you can create some very interesting patterns because the skip and select pattern between each period is totally random within your given range. Another tool we'll be releasing is currently called Match Surface. Maybe it will become another shrink wrap mode in the future. What we want is basically a SOP level solution to take any topology and wrap it against a target topology, as you can see here. The shaking here that you see is the tool try to target the target, try to get closer to the target as it tries to resolve itself. There's a difference between the new shrink wrap or match surface on the left and the traditional shrink wrap on the right. As you can see, they produce different results. It could be useful when you want to create some collision or dissolve completely geometry into a single mesh and use a clean topology to wrap it around it. Another geometry level tool that we made is symmetrical party reduce. This is to extend the ability of Houdini's pretty powerful party reduce SOP. One limitation of the party reduce as currently stands is that it doesn't have the internal support for keeping the symmetry if your input geometry is symmetrical. So basically we created a Ratchet tool to provide a workaround. This could be very helpful with characters, especially because characters tend to need them to be symmetrical in the party reduced version. So the major challenge is how to figure out how to preserve the UV islands, because the solution we used is to clip the geometry in half and just party reduce half of it. then mirror that to the other half. But then the other half's UV islands will be destroyed. So we'll pre-process the UV islands and trace along its the circumference of each island and pick a triangle, 3 points to form a triangle. Then using the triangle, it can pretty easily define the relative transform between two mirrored islands, color-coded here in red and blue. Then after the poly reduce, we could restore that transform. So here is an example of a high-res version versus a poly-reduced version. Here is what it looks like with the UV islands properly preserved. As you can see, the mesh, the geometry is symmetrical, but the texture is not symmetrical. We're happy to announce that SideFXLabs now have an ArtStation page. We want to make ourselves more available to the artist because this is a place where artists hang out and check out other people's works pretty frequently. And we want to make ourselves visible to you and just keep you updated to what we've been up to. We also update pretty regularly of what we're doing on the SideFX forum. We have a pin post that we document each release's updates and bug fixes. You can check that out and figure out if there's some new tools you need to upgrade, or if there's problems that you want us to solve, you can send an email to support and let us know. Now, thank you so much for coming to our presentation, and hope to see you again soon next time.
All right, I'm here with Diogo. Hello.
Hey. Hello, Chris.
So tell us a little bit about yourself.
Yeah, my name is Diogo Guerreiro. I'm from Brazil. I'm working in the industry for the last 10 years. As I started as a 3D generalist and was migrating towards VFX. And I founded my own company, CG Imagine, 3 years ago. And we are working on that, mostly for TV series.
Excellent. What are you going to be talking about today?
I'm going to be talking how to optimize scenes, how to work effective with a small crew, and to add a lot of value to the shots without putting a lot of time to the shots. So it's a lot of small tricks that you can add value and work fast and iterate fast and without the need of a lot of people and a lot of things going on.
Excellent. Well, let's jump in.
Yes. Let's get started. Let me give you a quick intro to myself. I've been working with 3D for 11 years now. My background is I'm a CG generalist. I worked for many years in Deep Blue Films, taking care of all the CG work. With time, VFX became a bigger part of my workflow and increased demand. And in the last 3 years, I founded CG Imagine. We are a small VFX house here in Brazil. And here in a small team, everybody needs to cook and clean up the dishes, if you know what I mean. So let me play a little reel from our works from the last year and this year. we used to work mainly in commercials and music video clips, but now most of our jobs are for TV series, and that's an incredibly increasing market for VFX. Even the simplest TV series has some sort of VFX. But my intro into this world was from the back door, and I couldn't even say that maybe not the most ethical one. Let me explain why. 20 years ago, I started doing expeditions, hardcore ones. I'm in the Guinness World Records for the longest windsurf journey, 8,000 kilometers. So 5 years ago, I did 2 other really hard expeditions. I walked across Greenland, coast to coast, and I also did 106 kilometers of open ocean crossing in a stand-up paddleboard. No boat again, sleeping on the board for one night between islands in Indonesia. So let me show you a little clip of these expeditions. These were for a TV series named Survival Days. I had also directed and filmed it myself, and why not edit as well. So this series I won as the best director, and it was the best reality TV series at Venice TV Award in 2020. So I was really happy to get that. Don't worry, we'll get to the VFX part. The thing is that these journeys were very hardcore, and pretty often we faced some technical issues like battery discharged, fog in the lens. So when I got back and started putting together the episodes, I started to miss a few key shots like the sun trajectory in Greenland. I couldn't leave my camera running for 12 or 24 hours time-lapse. So in Indonesia, when I tried to fly the drone, for some reason, because of the humidity, we have a lot of fog in the lens, and most of the shots was totally unusable. And then come the thing that there was no budget for VFX on this, and actually that was a TV series, a reality TV series. So VFX was not even something legal. But I was already working with VFX as my main source of income when not walking in the snow. So I decided to go for it and created a few shots, 100% CG using Houdini. Then was the dilemma of telling that to the TV channel or keeping to myself and hoping they wouldn't notice the fake shots among the reality ones. So I sent the episodes and they approved. But I wasn't feeling very good about that, and I decided to tell them before it went on air for millions of people. So then life showed its magical ways. The directors of the channel got impressed, and they asked if I could help them in another project about some indigenous tribes in Brazil. And it was a big project for me because it was composed of 21 VFX shots. We didn't have a lot of time and very short crew.
Nas profundezas do Pantanal, existe povo que tem a remada em pé como tradição.
Vamos fazer o que para mostrar que nós existimos?
Guató, uma remada no tempo. Sexta-feira, às 9h30 da noite, no Off.
I love to teach and to share knowledge. Learning Houdini was another dimension for my mental adventures. When I started in VFX and I started with 3D in general, it was another way of exploring the world with amazing characters in spectacular worlds, and that was so intriguing to me, and that was my main fuel to keep learning and improving my skills until it became a real job. So and this journey of learning Houdini is still going and going, always learning new things. I'm always following tutorials, I'm buying courses, I'm always trying to improve myself. And sometimes people teach you not something new in regarding of accomplishment something, but in the way that you can accomplish that. And if you can learn another way to accomplish something that requires less time, be more efficient, then it's always a positive thing. So the way I like to teach is to show the tools available to make the decisions, because there is so many paths to accomplish everything in Houdini or CG in general. Your skills, your hardware, the time that you have for that project, the camera position, all that needs to be considered before choosing which one to go. So let's dive in a few examples. And the first one I want to talk is the drone replacement shot. So we're going to understand a bit how much effort you really need to place on each stage of a project and the importance of Houdini's HDA system. So let me give a play in a pre-recorded session. I will start by covering the process of creating the shot for the TV show. This is not exactly the one that I used. I don't have the files anymore, so I'm recreating it using Houdini 18.5. So I'm just bringing some really rough lines that I did in Illustrator. And if you use a grid and use a UV project and a quick shade, and you need to keep the same proportions, you're able to set like some guides, like some background. And then you use it in another object node, so we get like a transparency for free, like a translucent. And you can just model. There is so many ways of doing it. We can use like a loft, doing some lines. I will do the loft when I do the camping tent for the snow shot. But for this one, I just grab a cube and just move a bit the lines, the points. I work in the half and then mirrored, and then did a subdivide. And I like to place myself the seams for the UV flatten, so I was sure where I wanted to how to texture it, and it's something. All this process took like maybe 30 minutes or something like that. It was really fast, and that's the point here, is to understand like for this shot, because it was a TV show, it couldn't look like a fake shot, so I knew already that I was need to shot from some distance, so I couldn't go that close, otherwise I would need to put a lot of time into this to make it really real. I always like to keep the poly count low, that you can UV easily. And for the backpack, I went through a different process using vellum. When you have this shape, the thing that you are concerned from the distance is how the light is going to interact with your object. So in the case of the bag, it's really important that you have like this kind of organic form, because you can see from the light, if it's just like a block, you would notice even from the distance. So I'm going to use a vellum, and also using the vellum brush, you can just quickly model and give like this natural look for this. I used to do a lot of things that I used to do like in Marvelous Designer, for example. I'm migrating for Houdini, a lot of cloth simulations, all that I'm doing inside Houdini, and it's so good to do inside one. If you can do it in one software, it's really good. So I'm doing a lot of that in Houdini, and even characters. I'm migrating after the KineFX. I'm migrating my characters to build it inside Houdini. So here's the result from the distance. I think it's good enough, and when you say that, you can move on to the next shot, and then you refine later. I want to cover a little tool that I created, because that's the power of Houdini. Every time you have a task that you do many times, or if you're creating something that you know that you're going to use many times, it's really worth spending more time to set a tool for that. So you have like all the parameters in here. And I created this because I render the oceans in Redshift. Redshift is my main render engine. So the Redshift renders ocean differently than Mantra because it's you just export some displacement maps and then you displace in the render time. So what I did, I created this tool, and this has a few parameters like the ocean sides and the ocean ground is just another plane under it that I can control how far it is from the other one, and it's just visible in the secondary rays, so only through refraction and reflection. So it's just there to be able to give some color to the ocean, you know, and you can control the color and the patches in here. So here's the displacement maps itself that I'm going to show you what I did. So it's 5 displacement maps all blended together. So we have like 2 large ones, 2 small ones, and so on. So let me go into the large mask, for example, and let's visualize it in the color. Let me just visualize. Yeah, here you can see the colors. So the white one is one displacement map and the black one is another one. So you don't have like the repetition. That's why we have this. And the same thing goes for the medium maps. And the small one is the very tiny details that is just small ripples with very high resolution all over this. So, and this is just a grid where we have like more resolution just to see the displacement. And we're going to cover that when I set up the scene with the boards in there. So let me show you how I cook them. So it's basically 5 different maps, and we export the texture itself on each of them. So we save the frame range that we want, and the big ones we have like a 10 resolution exponent, and for the small one is 12. It's very high res. So every step in here it's exponential. So just be aware that if you increase this more than 12, it's really high resolution. And the grid side is also being defined the size of the patches. So here we have a grid size of 125. The middle one is 200, and I believe it's 500 for the big one. So then you just cook this, and then you import in the tool. But you can mix that with flip simulations. You can mix that with to give movement to anything that's floating in the water, and I'm going to show you how. So I like to separate the nodes that I'm going to render. So inside another node, I'm going to bring the board itself and the bags all together. And I like also to work with my desktop divided in 2, so I can just drag from the object merge. And then what I need to bring is the ocean, the tool that I just covered. So I just bring the tool. I'm going to start with a 2000 meters map, and then I bring all the maps, the .exr maps that I cooked. And once you cook this, even if you have a generic look, you can play with these multipliers, the wave sharp height. So that's just a way of making the sea more rough or more calm. And let me show you. Okay, so that's the render, and of course I have like I can change the parameters on the texturing straight on the tool, and we already have like a very realistic ocean. So let me compare to you the different small waves, what it makes the difference. Like this is 0.25 here, a small wave 0.25. So if I increase it to 1, let's see how sharp it becomes. You can see that the difference is incredible. Look, it adds a lot of details, but then you have the feeling of wind. So here's the deal. Now if we allow the editing of content of the tool here, we can dive inside. And then if we go to the ocean grid masks, we have the main one, that is the big one that's totally flat, and it's just for saving the masks. And this one is just to visualize the displacement itself. So it's a smaller grid. I can make it like even smaller for us to visualize, like 100 by 100. And let me just, yeah, we can go even more in here so we can see more details if we want, like that. And then if we visualize this, you're going to see the displacement itself. And of course, it's not the same resolution as we would have with tessellation in the render time, but you can see the movement of the wave. And that's what we're looking for. And the thing is that this one, if we come to this VOP, what we are doing, we are bringing the maps, the displacement maps in here, and this is the multiplier that we are multiplying for the size of that, and we are extracting with a vector to float the UVs to U and V in the color map, and we are mixing them both using the mask, the black and white image that we had, and it's the same one of the ocean. Of course, all these should be the same, and then we are adding all that to the position, and that's going to displace it. So with that said, these masks are the same one as this one, okay? And then we get this in the end. And this should match the same thing of the displacement. And we can double check that. So for that, we need to move our board first to visualize, but then we need to find a way of having this natural movement on this board. And I'm going to show you how in a bit. So you see here, I just placed the board on the surface and just trying to match if the waves are looking the same, and you can see that it's matching, like the amount of part, a little bit of water in the back, and you can see also in my viewport and in the render. So it's just matching, it's just double checking. So now let's start to give the movement to the board so it matches the ocean. This technique I follow Rohan Dalvi. In his YouTube channel, he had a tutorial, I think 1 year ago, something like that. And it was a very simple way of just following the same movement of the ocean. So for my grid, it's a bit different. But what we do, we place a sort node in there. So then with the sort node, we can pick a point in space. But it should be before the displacement. So we pick in the grid. And the thing is that we can place a null out after the large displacement. So then we're going to get that grid with that point sorted, and we have like the 0, for example, close to the tail of the board. But you can pick any number there and place the board wherever you want in the grid. It's a good way of selecting it. So I'm just going to bring the grid itself. And then it's low resolution because we don't need a lot of resolution. Actually, we need less. We're going to even do a smooth because we don't want these very tiny movements in the board. We want the general wave, the swell being moving the board. So we can just compute the normals. So now let's group and let's select the board 1. And for that, we can just choose the group and let's say 0, for example. So we're grabbing the point 0. And that point is going to keep the same position, always falling. So you see the waves and the wave there is just following the correct position. If we do a copy to points in here, the board is going to come in a weird way, so let me just, we need to select the group because we want to copy just to that point specifically, but it's vertical, you see. We need to do something else. We need to set the up vector. And it's a very simple expression. So we're going to set the up vector to 1 in the y-axis. So 0x, 1y, and 0z. So I'm going to set that the normal is going to be the cross of the up and the side vector. But then it's going to be in the wrong direction. So I'm also going to say that the normal is going to multiply itself. If you do the multiply before the equal, it's to -1. So we are inverting it. And now the board should follow the correct position. That's really good. So let's see the ocean. It's very high now. But then it's about just placing a transform and place whatever you want it to be. But it's really effective way if you don't want any simulation. In our case, I just wanted the board from the distance. It's not even going to, I didn't even need to do a flip simulation for that. So I just wanted to have this movement in the board. And you can move this point along, and if it's a boat or something like that, it's also an effective technique. But if you want the waves the boat to react to the waves, you do in another way using RBG or other methods. Imagine a little noise on top of that, so the board is going to have like an extra movement, because if someone is on top of that, maybe you're out of balance, maybe there's a small ripple going. It's not like just to break up a bit. I made a quick animation for this. I used a software called Character Creator for that. It's not my main software. If I want to go really close from characters, I go in the traditional workflow using ZBrush. And in the end of last year, we start to rig everything inside Houdini as well. If you have a look in here, and that's the goal of that, is from a distance, I wanted to give some movement. So if you see just like a tiny bit of movement, someone just like pointing out, like if we would be talking and there would be like two guys, same thing. And then I use this plugin from a guy, let me see if I can, yeah, I don't know the name, his name, I think he's Russian, yeah, he's from Russia, and it's Material Extractor HDA, and it's a $3, and it's amazing tool that just optimize when you bring an FBF file, and then you just add this Material Extractor, and you can choose between Redshift and Principal Shader in Mantra, and it just plays a material network and extract all the materials from that character. So I brought the other guy inside and I placed him in the board. Then what I did is just pick a different point to copy to point, you know, like we can grab anything like 517 and the board's going to be in that place and it's going to follow along the ocean the same way. So it's really good, and let's have a check in the render. See, it's a bit too close, but look, it's so good, and the whole thing, the whole process, including the animation of the guys and texturing and everything, it's less than 4 hours, the whole thing. So yeah, you say look to this that close, it's really bad, right? But then from the distance, that's the key of this all this lecture that I'm talking here. It's all about this, to understand what do you need for that project. And in this case, I'm redoing a shot that I did before, so it's even faster. So it's all about how close you can get being kind of sloppy in the setup of the scene. If you want to go really close, if you want to do this for real, then it's going to be a lot of work. Like it's a exponential, I would say exponential amount of work. It's not just linear, you know, like from this distance, you spend like 2-3 hours. If you go like maybe 10 meters closer, you spend like days or even weeks. So just keep that in mind, but it's really fun to do that. And I'm going to show you the render. So here is connected with the real clips. The one that I did for TV is a bit different than this one, but yeah, you see one day, if I put like 1 week, that's a reasonable time, you can bring it really close to reality. So powerful tools, think smart, and don't waste time doing things that's not going to be visible. Let's approach our second shot, and it's the Greenland time-lapse. I couldn't do long time-lapses in Greenland, and I wanted to show the trajectory of the sun throughout the day. We're going to do some simple modeling techniques in Houdini. We're going to cover a bit of the height field system, and we're going to do some scene optimization. So here is the reference of the tents that we used in our expedition and the snow itself. So the tent is pretty simple, but we need to follow along a few things so we make it believable from some distance. So I'm going to start modeling this, and I'm going to start with a simple shape as well. For this time, I think the cube is the best one to go. That's an easy choice. So I'm going to bring down a tube, and I'm going to use in the z-axis. And the measurements, I'm just going to be some approximate. I'm not doing something really to scale. Like it's to scale, but it's not in the centimeters range. It might differ. So around like 4 meters, I would say, is the length. And if you change this, you're going to change the extremities. So I'm going to do just a generic change to, now I need to reduce that 115 and 4 meters in length. And the amount of divisions that we have in that, it's something that we need to check, because I want to have the same amount of subdivisions of the supports. Like we have 4 supports there. I'm going to place it 4. Great. And the thing is that I always like to work as minimum polygons as possible in the beginning, as much as you can. And if you go all the way to the end with very few polygons, that's great. Easier to set up the UVs, easier for handling, very light for it to render. So it's really good. But of course, sometimes you just can't go that low poly, So I'm going to use a poly bridge to make the full circle. So if you select the edges and in the destination group, the other one, we could do it procedurally as well, but I'm just iterating fast. And the thing with doing procedural work is that saves you time if you're going to reuse that again, or if you want to make changes and the whole chain is going to react to that. But sometimes if you have something specific in your mind and you just want to do it really fast, of course it's faster sometimes to just do like this non-procedural modeling. So what I'm doing now, I'm grouping that edge, the bottom edge, because I'm going to use these labs to add to, it's called like, it's a labs tool that's called, let me just recap, I think it's edge group to curve. Yeah. So what it does, it creates, like if you have a group in the edge, it creates a curve from that. And I'm transforming it to the front. So in the positive Z, around a meter, maybe we need more. I'm just going to merge just to visualize, but we're not going to use the merge. So yeah, around a meter. What we're going to do, we're going to ray that, the top part to the bottom one, and we're going to have like the closed part of our tent down. So I'm going to do another group, and I'm just going to select the points. So we have like 5 points selected. Let's call front top, and we need to have the same amount of points. We have already 5 points there because it's just what we had in the bottom. So then it's going to work well for us. We need to ray, and we need to get like the front top, and the collision is just the minimum distance. But for that to work, we need to create a poly loop. Otherwise, it's going to just bring all that points, and we want that point to keep in the same position as they are. Just create a poly loop, and then the group itself, we need to double check, place the group afterwards, and the selection is working. So perfect. We did a nice way. And now if we move the transformation there, we just change the shape. And to close that, we can use just another poly bridge. Now I want to prepare the poles. So we need to select the loops and do a poly bevel to just extract the thickness. And Yeah. If we set the group, we can do another one. This time we select the ones that we did before. And you see, sometimes it's just hard to select the edges like this, for example. It's very tiny. And because it's procedural, what we can do, we can just go ahead and increase the size so we can select very easy. And then we can always come back and just, we're not changing the poly count, so we can just change again the size and the selection is going to be there. So it's just easier way to work. I'm going to use a pick to extract, but I didn't like the connection there in the bottom. So I thought maybe the poly extrude would be a better solution for us. So yeah, it didn't quite work, the pick. What the pick does, it just push points towards the normal of each point, but it worked really well with the poly extrude in that case. So yeah, perfect. I add some divisions, and I didn't do any subdivision yet. We will do that later to see how the tent's going to look, but we need to do other creases, like some edges, to do like some poly loops around some edges. So I'm going to use the knife to cut down the whole bottom of the tent itself. And now if I subdivide, it has a great shape, and the poly count is low and it's working perfect. We're going to work now in the ventilation of our tent. So just selecting a few polygons in the front and the back, wherever is the front and the back is symmetrical. And now let's poly extrude. And if you can change the front of the extrusion to give a different shape. Next, if you make a polygon selection of those points, you can use a fuse only on those groups and fuse them together so the shape get this like similar to what we have in our reference. Then I'm going to select a few edges to make for the UVs. I want specific edges because I want to separate based on the texture that I'm going to apply on each of those. We could use the SideFXLabs UV, it's a great tool, but sometimes when you model something like very low poly like I did and with a very clean topology, it's so easy to select the edges that you want to extract for the UVs that just worth spending like 2-3 minutes doing that. So it's a great way. Deselecting this loop that we don't need. We can have the whole bottom at once, and great, we have nice UVs. So if you use a UV layout, it's going to place everything, very clean UVs as well. Let's place the normal. Now I have the low poly with the UVs. I want to generate a higher poly, and we're going to apply the same technique that we did with the bags. So we can use the vellum to just give that organic shape to the tent, to give the feeling of that's not a rigid thing, you know. So I'm remeshing it first. Then I decided to go with voxel mesh and increase a bit the dilate a bit, gain a bit of more volume to that, and then we can remesh this. I was kind of trying to figure out the best approach for that. So if the voxel mesh helped anything, and then it didn't. So the remesh worked well. Then the vellum constraint, just changing a few parameters. So I don't want it to be very stiff, and I want to enable plasticity on that. So basically it. And then we use the brush and just play a bit and then tweak. There was a viewport bug, and you see, yeah, it gives a very good, nice organic shape. And the thing with this shape even if we're going to see from the distance, it's not the details that you're going to see, but the way that the light is going to interact with this object would tell to the eyes that that's something weird with that, or it's something natural, you know. And because we're going to do a time lapse and the sun is going to change position, during this transition of the sun, the light will change. And what that would do is going to even highlight even more this organic shape. So that's really important. And the vellum brush is a great tool. We don't even need to simulate anything. It's just going to be just touching here and there until you're satisfied with the shape. So now that I have the shape defined, I want to do a point deform, and to point the form using the high-res mesh that we distorted using the vellum process. But the number of points in the vellum brush is the same, so we can use those to deform the geometry. And now we have the low poly also deformed in an organic way. So for the lines that sustain that holds the tent, like I just did a line that would have more or less the same length of the tents, and just kept the points using an add node. So I wanted to make a selection of those points. I tried to think a way of doing it procedurally using like the normals and the height, but in the end I prefer to just use a bounding box. So just select the top part, place the bounding box wherever I wanted, and you can pick a few points. It wouldn't matter, because the thing is that we would just use a fuse to connect by proximity. So yeah, you see, if I use a fuse increase, then I get 4 points. The numbering is in the wrong order, so I want to add a sort node, and based on the z-axis, I'm just matching the numbers there so they make sense after the merge, actually, because I want all of them to connect based on the group. So if you do like a group n of n points, you get like these pairs of lines, and that's exactly what we need. Use a sweep node, then we can get the correct thickness for the line in a very simple way. So that was the best way that I found to give the line. And the line also is some small detail, but it's going to be visible in the light. So now with very clean UVs, it was pretty easy to texture the scene. And so I just went to Substance Painter again and tried to capture a lot of small details like the snow on the top of the tent, and the different colors to get the color right, and also the logo there. I think it's an important feature for the distance. So here's just a quick render to show you the work, and we're looking very close to the tent and it's looking good, but for the shot we're going to be further away, a bit of backlight, so we're pretty safe. So you can see the reference. We have this very flat area, that's the ice cap of Greenland, and it's completely flat, but you have like this wind-swept snow on top. It's kind of in this day, for example, that didn't snow for a few days, very cold. So we have a lot of interesting details that we're not going to accomplish all that just in the height field, but we need to give a good base, and then we do the extra details in the texturing stage with some displacement. So starting by having a 1000 by 1000 grid and using the Wally F1, gives like this kind of geometric shape, but if you place a very low element size and a low amplitude, you give these nice undulations on the whole terrain. And then we can do another one. And just the same idea of the ocean, we're going to displace it a bit different, so it's going to be a bit different than the other one, and then we're going to mix them both using a noise. So then you don't have the repetition, not only in the texture, but in the displacement of the terrain itself. So that's a really easy technique when you are afraid of having it like these repetitions along the whole thing. So the red area is going to have one and the white area is going to have the other one. And if you use the lattice warp, you're going to twist that a bit, the noise. And this gives this wind swept look to the terrain. And here, so use a height field layer and use the noise as the mask. So it's one on top of the other, masked by the noise itself. So also we need to have like a bit of ondulation in the terrain. So it's flat, but I want to have like just a bit one. And if you use an alligator noise, give kind of a nice look for that to break up the terrain a bit. And using the gradient warp with a 0.2, you're going to start having these weird shapes, but this looks really good. We can use a distort node and distort it a bit with element size a big one, because we just want to move the whole mass just to tweak a bit, nothing too much. And I'm going to erode just like maybe 8 frames, something like that, just to break up a bit. It's not like a totally necessary step for that, because the erosion here is not playing the role of really simulating what happens in the snow in this case. We just wanted to break up a bit the lines, and using the height field clip just to clip the top edges, because it's kind of a plain top around. There's no points in the snow because the wind would just sweep that away. So we want to look to the reference and keep this nice look. And I'm also blurring the terrain a bit. So we have like just these ondulations, and they look really great with the low angle. And if you layer on top, adding that on top, and we don't need any mask, we're just adding that on top of the other one. So we have like this kind of a breaking up on the terrain, and that's really great. So restarting the simulation, I want to have a bit more resolution. So we can add, after the layer, we can add just a distort, and because then it's going to create these shapes of the wind that create these lines that have like this nice flow shape along the whole terrain, and it's really cool to have that. So now we need to convert the height field to geometry, and at this point, if you have a lot of resolution, it might start to have like a lot of polygons, like more than 10 million polygons. And what I'm going to do, I'm going to show you a way of optimizing your scene so you have more polygons in the areas that you need and less in the other areas. So I'm just creating an attribute called retention, and this attribute is read by the polyreduce. And you can do it non-procedurally, just painting the areas that you want, use an attribute paint, or the best way to do is use a volume, and then you set to the camera and place your camera there, and then the camera is going to define the volume, and you can use that using an attribute transfer to transfer. No, actually is a attribute from volumes, and you're going to transfer this attribute that we're going to name it retention, and it's going to capture that information from the camera into your geometry of your terrain. So I'm just going to set the name as retention. I'm going to set the value of 1, and then we're going to drag the volume there, and we're going to have this retention. But the thing is that we want to have to retain in the area close to the camera that the camera is going to be looking at, but we don't want to have like a zero retention in the rest. We want to have at least some. And then we can just do that using a point swap, and we can blur the retention attribute so we have like a better transition if we want. It wouldn't make a lot of difference, but sometimes it's good to not have a harsh area. And we can do a point swap to set a minimum retention to everything. So if you bring using a bind node inside your VOP, let me just go in here. Yeah, let's do a bind node, and then you bring retention, and then you can do a fit range and export the retention outside. And the minimum, the destination minimum, we set to 0.3. So now we have the retention, and we have 3 values there. If we change the float to attribute size to be 1, we're going to have only 1 attribute. And we just need a float value from 0.3 to 1 in our case. So then the poly reduce, you have this retain density by attributes. So we have already set the attribute retention there. It's by default retention. So let's say like we want to do 20%. So that red area, it's not going to be affected by that poly reduce. It's going to keep more polygons, and that's great. I created this node texturing, layering different texture in Quixel Mixer using Quixel Bridge assets, and that's going to give us the last definition in our terrain. So for the sleds, I used a different technique to model it. I use a draw curve, and then I use the resample node to just smooth the shape, and use the skin node to bind everything together and to give the geometry to it. So the last tweak for texturing the terrain, you can see that I increased the subdivision, the tessellation, and gave a bit more definition to it. And also these little tiny sparks in the texture. And that's coming from a noise that I'm placing the emission color. A very tiny noise, so 0.66. I animated it because when the sun was too low, we don't want a lot of this emission to play a big role. We want it to be more when the light is touching it. So you see here's the glow. So that's why I animated. So I had like a lot of emission when the sun was higher and no emission when the sun was very low. And that gave just the final touch. Here's the final render. So I built that all in 3 hours, very little time, and gave a decent result. You can improve that if you put more time, but it's really good to be able to accomplish something like that, making smart decisions and do that in a short period of time. That's great. So let's go for a next example. So by last, we're going to cover some environment techniques. That's part of my course, Faraway Island. So we're going to learn how to manipulate the terrain for simulations, combining different large-scale flip simulations in a very optimized way, and integrating simulations with an ocean grid. So let me play a pre-recorded video. I want to start sharing a cool way of digging more the river, so we have a better simulation. So I'm just extracting a plane from the surface and editing it in a way that we can then make like a boolean from the terrain using that plane. And that's going to give not only like a deeper river that you can control how deep you want it to be your collider, and at the same time to give like some texture to it in displacement. Like, because if you add a noise to your plane, when you do the boolean, the terrain of course is going to capture that that noise. And that's a really good way of just setting that in the part that you're going to simulate, because you're not going to simulate the whole scene. So you're just focusing one area and doing this Boolean fracture. And it's really great to work like that, because you have control over how much deep you want it to be. Because when you are doing the height field node and you're playing with the nodes, you can't be very precise in every element in your terrain. It's much easier to give the general shape and then going from there. Always keep your eyes on the reference, because in the big waterfall, the white water is more important than the flip sim, but the flip sim is the base. So we can do a basic flip sim and extract the data, the velocity and the vorticity, and we can use that in the shader to help to sell the idea of the white water, the speed that comes, and maybe just the start you can see the water. In a very high res sim, you'd have around 100 million particles in a white water simulation. For this one, I have only 7 million, not 77. It's very few particles. And the thing is that if you have a lot of motion blur and if you do some other pyrosim on top of that, you can leave without simulating like a lot of particles. And you can always use a point replicate that's going to just put points around it and use some noise just to give more volume for that. That's not like a high-end production workflow, but it's something that if you need to simulate something fast and you don't have a very strong machine, you can just survive doing that. And you can layer different simulations and just tweak a few parameters and another one and render also like in different passes. And then what I'm doing here, I'm just selecting the areas that we have like a more depth, and I'm using a rasterization because I want the volume to be more in the areas around the base of the waterfall, that it vaporizes more. Let me explain you how to combine different large flip simulations into the scene. So we have this that's going to be our flip tank, where we're going to have like a lot of particles, and we're going to use some waves to move those particles against that wall. So that's one flip sim, and we're going to use a wave force for moving these particles. And then we have the waterfall. The waterfall has a velocity, all these attributes that we already have. The velocity that is going to interact with the other flip simulation. We're going to use that to distort also and create these ripples around it. And then, by last, we have the ocean grid. That is just a displacement. And this displacement should match the flip simulation. And we're going to do that having an area of flat surface before the flip simulation starts. And we're going to displace that exactly the same way that we're going to displace the ocean grid. And with that, we have all the colliders and everything is going to match. So for the ocean flip simulation, we use the ocean spectrum to generate waves. But these waves are different than the one that we use for the displacement of the grids, because these waves are just to generate velocity. When velocity comes in rows, in lines as waves, it's going to give this wave look to our flip simulation. And that waves are going to be moving and simulating, hitting the wall or any colliders that we set. So we need to do that, and we need to set the correct direction, how much sharpness we want, and how much alignment we have. But the visually looking to the spectrum is not the waves that we're going to see there. They're just the forces. So think about the first pass, you just need to generate forces. Every flip sim, they're going to be moved by forces. And these forces can be using like a line that has velocity on this, a body that is falling, any type of velocity. In this case, we're also using the ocean spectrum to generate velocity through waves. But we need to mask a few things because we need to have that flat edge that we're going to be later combining with the ocean grid. So we use a VOP to just have like no velocity in the beginning, and then the velocity will just start after a little bit further down our grid. So here you see that we have the beginning is really flat, no force, but then the velocity of the waves start to going further. Always start with a low particle separation, like 0.1, for example, just to visualize what's going on. So we can take advantage of the attributes that were generated in our waterfall simulation. So the water is falling and it has velocity on it. So like we did with the waves and brought the ocean spectrum waves force, we can also use the velocity of the white water, not the geometry of the white water, not the geometry of the waterfall, but the velocity of the waterfall to displace and to play against the other simulation. So that's how we did this. You just bring the force of the waterfall and it's going to interact. And of course, this is very low res, but you get the idea. And that's a great way. You don't need to simulate everything in once. You do one simulation and then do another one, and to see which elements you can extract from one simulation to interact with the other one. So in this case, what interacts with the ocean is the velocity of the waterfall falling on it. So, and you can multiply the velocity to get like more or less disturbance in the area that you want. So we combined the waterfall with the flip. Now it's about combining the flip with the ocean grid, because you don't want to have a flip simulation covering the whole screen because too much particles. So what we need is that flat part we need to displace that the same way we displace the whole ocean. And we can use the same HDA that I created that we talked about in the pedal scene. And we extract that data from that and displace the same and place the same displacement on the grid. But we need to mask out the velocity and the vorticity out of that, because we don't want to displace things that are already moving fast, like waves or anything ripples. You don't want to add a displacement on top of that. You want to displace the flat areas that has no velocity. So we don't also need to use both displacement that we have, like the black and white. We can put just the white area around the area that we want, and then we use only one of the displacement to do that. And in comp, we're going to separate that element. We're going to render just the flip sim with the displacement on that and just the grid. And we're going to combine both of them. So we're going to have like a totally seamless transition between the flip simulation and the grid. Matt Puchala created this awesome plugin called Axiom Solver that works pretty fast in Houdini for pyro simulations. And I used his plugin for creating the mist of the connection of the waterfall with the flip simulation, and also the mist around the waterfall. When it's falling really fast, you can see this kind of a smoke going outside of the waterfall. And with Axiom Solver, it's so fast, and you can create this and you can iterate really fast. You can try and make a few parameters, change a few parameters, try again and test again and test again. So it's really fast to see the results that you want. And I totally recommend this plugin. It's for free, but please donate if you like to use, because it's such a great tool. And I use that for all the mist around the waterfall. So here you can see that just the mist there. I'm not using the white water, and here is all together. And just keep in mind that this is just a low-res simulation. I just wanted to prove that it's possible to do something in any computer, just doing low-res. If you go for a real work with that, like a professional work, you just up-res all the simulation and you're going to get, of course, a better result. So this is my course, Faraway Island. It's a Houdini environment complete course, more than 17 hours. So if you're interested in that, I have it for sale in CG Circuit. So, and you're more than welcome to join us there and ask me any question, and I will be more than happy to help you out. Thanks SideFX for the opportunity to let me share a bit of my work, and thank you for watching this Houdini Hive. See you in the next one.